Hey guys, I just wanted to take a quick minute and show you an emergency repair that I'm about to perform on this Lennox unit. Real quick, there's a picture of our model number for those who are interested. This Lennox unit uses a 2051 EMS communication board with an off-site energy management company. And what we had happen is our zone sensor, which I pulled off the wall downstairs, our zone sensor failed. It's a non-stock item. I don't have it. It'll be probably about 2 days before I can get it shipped to me. So what I'm going to do is I'm going to take this thermostat I have over here. I'm going to wire it to our communication panel, and then I'm going to drop it down our return air vent. And that'll get them by for now. Now this particular energy management board has, on one side of these relays, you see all the relays over here, on this side of the relay we have a constant 24 volts, as you see right there. So, and real quick, this repair only works if that EMS board is operational. If that board has failed, there you can still bypass it and get them up and running in an emergency. You just go right to your 24 volt transformer, you hijack 24 volts, run it through a thermostat, and then have the Y1 signal go through your high pressure, low pressure, and then over into your contactor, and then also to your indoor fan motor. But that'll be another video for another day. So right now what I'm going to do is I'm going to take and I'm going to wire up that thermostat. So I have a red wire hijacking the 24 volts off of this, and then it's going to go through the thermostat, and then because it's warm out, it's going to come back through the yellow Y1 wire, and it's going to land on this side of the relay, essentially closing this relay and kicking on our cooling circuit. Also, I'm going to wire in a green wire to go up here to this side of the indoor blower motor. So this way we also obviously have an indoor blower motor as well whenever we have a call for cool. So that's what I'm going to do right now. I'm going to get that wired up, and as soon as I am done, I will show you the final product. I got my temporary thermostat wired in place. I'm going to drop it down my return vent, and then we're going to power this thing on. Keep in mind, guys, this is just an emergency repair. This isn't something I do on the norm to get around actually fixing stuff. But one day this video could save a long and drawn out phone call trying to explain to somebody how to do this over the phone. So, and also while you're doing this, make sure on the thermostat before you drop it down that if it's a programmable thermostat, you have it programmed properly. Make sure you have the fan continuously on so air is constantly circulating through that vent so that thermostat can sense it a little bit better. And also what I did, I just popped the top of this. I ran my thermostat wire up through the unit. It really only takes 5 minutes rather than just leaving it on the outside and running it over top of the machine or under the machine or something. But I mean, only took a few minutes. So yeah, that's how we temporarily get a unit running that has this 2051 Lennox communication panel. All right, guys. So hope that helps somebody out there in the world. All right, like and subscribe, guys. We'll see you on the next one. All right, guys. So today we are back at a job that I filmed about a week ago, where these rooftop units had skyrocketing head pressure, and I suspected that's what killed our pressure switches. So today we are back on site. I have my pressure switches jumped out. My thermostat is bypassed, so I'm in stage 2 cooling. My head pressure isn't as crazy as it was last time. The last time I was here though, we were pushing 95 degrees outside, I think. Today we're just a hair above 70. My head pressure is a little bit higher than normal. Condensing temperature is about 110, so we are a little bit high. But what I really want to emphasize in this video is the difference it makes when you split and clean a condensing coil. So what I'm going to do is, of course, as I just did, show you the before, my pressures beforehand. And I've already got the top undone. I'm going to peel back this top, and we're going to split that coil, clean it, and then when we're all done, we're going to recheck our pressures and see how big of a difference that made. All right? I'll bring you along for the ride. Show you real quick, guys. We got our coil split. I don't know if the camera's really going to pick it up in between there. It's not as bad as I thought. It is pretty bad, don't get me wrong, but it's not as bad as I thought. Got a little bit of some cottonwood up there. Way down inside there, you see a little bit of a blanket in there. That's kind of how it is through most of the bottom there. But we're gonna get it all cleaned out, put it back together, and see what our pressures are after that. Alright, so I'm gonna get this coil nice and wet before I get some chemical on here, but get as much surface crap off here as I possibly can. You can already see some of the crap coming out of the inside of the fins here. What I like to do, I'll go straight down, and then I'll go from the outside in and the inside out, basically. But I try to push everything straight down off the surface before I do anything. For example, if I go like this and go from the inside, I'm going to push everything on the surface, the outside surface of this inside coil to the back of this outside coil, if that makes any sense. So first, you're better off to try to push all that crap right straight down. So that's what we're going to do first. Look at that, you can already see all the crap coming off of there. I think the last time this was cleaned was about 1942. Not even being sarcastic with that one. Alright, let me get two hands on this. I'll bring it back when we start doing our chemical soak. I'll let that soak on there for about 5 or 10 minutes. Really get in there and break up all that garbage that's been on there for the last 21 years. And in case any of you guys are out there wondering, I did recommend these units be replaced. They are 21 years old. I think if you look back to the video labeled Hvac like it's 1999, that's where I was originally out here diagnosing these units. So, alright, let me let that soak for a little bit longer, and then we'll rinse it off. Alright, get all this chemical off here. See all that brown runny stuff coming out the bottom? Yeah, I'd say she was overdue for a cleaning. And again, I'm just trying to push everything straight down because I don't want to go from the outside in and blow it onto that secondary coil. I don't want to go from the inside out and blow it on the primary coil. So I'm just going to go straight down for a little bit. Not too bad. Looking better already. Alright guys, let me get this wrapped up. Once I get her back together and get my gauges reattached and get her running, I'll show you what our head pressure looks like after that, alright? Real quick guys, in case this isn't obvious, I just wanted to highlight that I have just some blocks right here supporting this outer coil. It's probably pretty obvious why, but when you split these and you have the secondary coil kind of hanging outside of the frame, you run the risk of cracking a copper pipe somewhere, so always support this outer coil with something. I just kind of found something right here on the roof that supported it, so alright, keep that in mind. Don't break your coil. I just wanted to take a minute and point out how dirty this blower wheel is. I originally didn't plan on cleaning it, but not on this unit anyway. But as I got to looking around, the inside of this thing was just gross. I'm hoping that's coming through on camera. But you see all this garbage everywhere down here. But this goes back to take your time, take a look at the big picture. It only takes a few minutes to pull this out. I'm going to spray it off, get it nice and clean, put it back in there. This way we're going to have proper airflow on our condensing coil and on our evaporator coil as well. So no point in doing one without the other, you know. So alrighty guys, let me get this clean, and as soon as I get this started back up, I'll bring you along and show you what our head pressure is like this time. Alright guys, so we got this unit all wrapped up finally. Condensing coil's nice and clean. It's been split, as you've seen. The indoor blower wheel was also cleaned. Just a quick recap, when we first started and I showed you the initial pressures, our ambient temperature was 73.7 and our condensing temperature was 110. So that gave us about a roughly 37, 36 degree split. Now, right now, my ambient temperature in about the same spot as I had it before is 81, and my condensing temperature is 110. So I'm looking at about a 29, 30 degree split, which is perfect according to my rule of thumb. So it was a lot of work, but we got 7 degrees out of that split. Let's see, take a look at our supply. 47 on our supply. And a nice cold return of 68. So I'm sure we're freezing them out down there. And that's our 20 degree split right there. Let's go over here, see what kind of CFMs we got. Hold on, my hat's malfunctioning. There we go. That, judging by the shape of my hat, I'm gonna guess that's about 200 CFMs. No, I don't know. That's probably 200 CFMs. That's just a guess, but just some food for thought there, guys. So, anyway, the point of this little video is make sure your coils are split. It does make a difference. Even if it's only 7 degrees, you're going to extend the life of this machine, all right? So, hope you learned something. Like and subscribe, guys. Hey, guys. So today we are back on site at this York unit. About roughly 2 weeks ago now, maybe a week ago, I had an ignition board fail in this unit, and it won't go into cool mode because the main control board is getting a signal from the ignition control board saying that one of the thermal limits is tripped. The ignition control board is bad, so I was able to just bypass the main control board by hijacking 24 volts, routing it through their thermostat, through my pressure switches, and then into the contactor coil for my cooling. So today I'm just going to remove my temporary repair, and I'm going to install this ignition control board and get this unit up and running properly. Now, while I was doing this, I came upon this unit, which is equipped with an optional power exhaust, a power ventilator, power exhaust, whatever you want to call it. If you look down there, when I first got here, I noticed the door was really hard to open. I didn't really think anything of it until I came up here and I seen that this power ventilator is on. So essentially, we have an exhaust in the building right now. This is sucking air from downstairs and blowing it outside, creating a negative pressure inside the building, which was the reason why the door was so hard to open. So I am going to delve into this unit real quick and see what's causing that power exhaust to be on right now. As far as I know, there's no pressure sensors set up downstairs. This building doesn't seem to be equipped with any sort of barometric pressure sensors that tell the unit when it's under positive or negative pressure. So I'm not real sure how that's set up yet, but I'm gonna delve into that real quick and see if we can't fix that, set it up properly, and I'll bring you guys along for the ride, because This is sort of a new one for me. I don't see too many of these around my area. As you can tell, our power exhaust is now turned off. Let me show you what I did here. So I had to bust out the manual, kind of read up on some stuff. I'm not real familiar with these power exhausts, so if anybody watching is familiar with these, please leave me some comments, some tips, some advice. This is, I don't know, maybe the second one I've ever seen on a rooftop, but luckily I found a manual. So according to the manual, the power exhaust comes on when the economizer dampener position is at a certain percentage, right? So I got to looking at my economizer control board, and I noticed that it was set, this minimum position right here was actually set to the maximum position. My free cool was set to A, which is I believe 73 degrees. I set it to D for about 63 degrees. That's just kind of what I've always been told to set it at in Michigan here anyway. We don't want free cooling unless it's, 60 degrees outside during the fall months. So looking at this exhaust set point, it was set to 2 volts DC. My minimum position sensor was set all the way open. And also my minimum position set point was all the way open, but my economizer damper was closed all the way. So I believe there was a problem with the set points. And again, I'm not real familiar with these. So I adjusted my minimum set point to its lowest setting, and then I adjusted my power ventilator set point to the 10 volt signal. Because I read over here, blah, 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 with 2 volts DC corresponding to full closed and 10 volts DC corresponding to full open. So what I believe that means is when the economizer senses that the air is at the proper temperature, it will fully open. And when it does fully open, the power ventilator will come on. So my minimum position sensor, like I said, was set to fully open, and my free cool sensor was set to 73 degrees. And today it's about 75-ish. So I believe the economizer was trying to pull in outside air for free cooling, but again, my damper was closed. So I adjusted everything properly. Again, I adjusted my free cool down to D here, so it's 63 degrees, I believe. Let me just double check here in my handy dandy manual. Let's see, yep, D is 63, A is 73. So we are set to 63 right now on this. Our minimum position is all the way down. Sorry, my hand's in the way right there. Minimum position is set all the way down. Our exhaust is set to 2 volts DC right now. And then with all those settings, as I was adjusting those, my damper never moved. I could hear the motor whirring. I know I had power to it, but the damper never moved. So I got to kind of looking, and I found over here this little arm going to my damper was broken. So what I believe was going on was my economizer was trying to call for free cooling, and it had thought that it was opened up all the way. That is why the power ventilator was coming on. But since the arm was broken off, the damper wasn't opened all the way, so I was essentially just sucking air out of the building, causing my negative pressure. So that's what I believe is going on, or was going on. Like I said, I reset everything. I'm gonna let the customer know what's going on with this economizer, see if they want to submit a quote to repair that arm or not. Yeah, and we'll go from there. Well, like I said, guys, if anybody out there is more familiar with these, please leave me some comments. Let me know if I missed something. If you see something that I'm not seeing right now, let me know. I am not real familiar with these, but like I said, luckily there was a manual here, so I was able to get a little bit of information and kind of solve the problem the best I know how. All right? Alrighty, guys. Thanks for watching. Like and subscribe. So today, we got a York unit. Actually, I take that back. We have 4 York units that apparently are all doing the same thing. So I'm going to start with these two right over here. The issue is they'll run for about 10 or 15 minutes and then they shut off for about half hour or so, and then they come back on, run for another 10 or 15 minutes, and then they shut off. So I got up here and I had the energy management company kick in the unit for a call for cool. I checked my supply temps. My supply temp exiting the unit is 46, and take a look at the vent over there. And right before it gets into that, I guess what I call a duct box, that box that goes straight down into the building, right before it gets over there, I have 46 degrees as well. And then once we get into our control panel, let's see if it's going to pick it up on camera here. It is telling me that it is locked out on excessive temp in cool mode. Right there we go. So I did some research. I found a manual for that control board online, and what I've found so far is that the board by default is set to go into this fault mode when the supply temperature gets below 50 degrees, and obviously 46 is below 50. So now this unit I'm just gonna leave running right now. This is the one I'm focusing on. I just took you over there to show you that fault code real quick. But what I'm thinking is that we're just not moving enough air through here, because when I pulled this panel off, I can feel inside here. I mean, this motor is nice and cool. This thing is just really cool. It's almost like it's not moving enough air. I checked rotation. We're going the right direction. I changed the belt. Belt's nice and tight. I might adjust that pulley. That might give us a little bit more airspeed. So I'm going to close that down. Actually, what I'm going to do first, I'm going to take an amp draw of that motor with this cover back on, and then I'm going to pull that cover back off, close that pulley, and then do another amp draw and see what our temperatures are then. I'm assuming once I close that pulley, I'll get a little bit more air out of this thing. I mean, I don't see anything else. I pulled the filter panel off, checked to make sure there's no obstructions in my vent. I haven't done a static pressure test yet. That's on my list of things to do. So let me get an amp draw of this motor, and I'll bring it back around when I figure out something. All right. Our unit just came on. Our blower right now is pulling 4.5 amps. I'm going to double check the voltage. On the motor data plate, it says 7 to 7.5, rated at 208. I'm not sure if we're doing with 460 or 208 just yet. Yeah, so this is a 208 system. Now, assuming our motor is wired correctly for 208 instead of 460, our amp draw should be 7 or 7.5. So, shut this off. I'm going to close that motor pulley, and then we will redo this little test. I have my blower motor pulley adjusted now. I didn't get the amp draw result I was hoping for. Set about 4.9. Before I adjusted the motor pulley, before I closed it down, I had 4.4. I was kind of hoping that I would get closer to 7, because the motor data tag says at 208 I should have 7 to 7.5 amps. I guess I'm not familiar exactly with what conditions that motor was rated at, but I have noticed my supply temperature seems to not be dropping as fast. I'm hovering around 49.50, which is normal. I was doing a little bit more reading on this unit, and there is a way to disable the SAT, supply air temperature alarm fault condition. If you adjust the supply air temperature down to 0, it'll disable that function. So I think I'm going to go ahead and do that after I check a few other things. I want to check that blower motor just to make sure it is wired for 208, not 460. I just installed these units 2 years ago, right from the factory, and we didn't do any sort of rewiring or adjusting or anything like that. So I can't imagine that the motor's been rewired for whatever reason. Also, if the motor was rewired, I imagine it would probably be very, very hot or not really operational at all. So I don't believe that'll be our issue, but we'll do some more digging. I got my static test just about ready. My battery died, so I'm going to change that out, and then we will revisit this situation. All right, here's where we stand on this unit, guys. Right now I'm looking at about a 48 degree supply air temperature. I do have some sort of static pressure test going on here. I don't do a whole lot of static testing because a lot of what I do is just rooftop package units, which sit on ductwork that is about 20 feet up in the air, so I don't really do a whole lot of static testing in my area. But from what I've read online and the videos I've watched from the guys who are really good at static pressure testing, that seems to be pretty high static pressure. I'm pulling back 70 degree air right there. So what I've done is I've decided against disabling the supply air temperature alarm where it shuts off if it gets below 50 degrees, or 55, excuse me. What I've done instead, let me see if I can show you this little display here. There's a little bit of a glare on there. I apologize for that, guys. So if you go to this control, I hit enter. I'm going to scroll down until I get to commission, hit enter. Then I'm going to scroll down until I get to CLG for cooling. Scroll down until I get to SAT low set point. Hit enter, and if it's picking it up on camera, you'll see that it's at 40. That was at 55. I lowered it to 40. I decided not to disable it just in case one day if I figured if a belt were to break on this unit or somehow we had airflow issues again, that at least at 40 degrees it would shut off before any damage was done. It wouldn't freeze up or anything like that. So that was my line of thinking with that. Hey guys, I just wanted to take a quick minute and recap that last job we did. So we had just the two problems there. The first problem was the factory set point for the supply air temperature low alarm set to 55. I don't know why it was set to 55. Maybe there's something I'm missing on that unit, but I've always operated under the rule of thumb that air coming out of a unit should be closer to 50 degrees, and of course 55. If it's set to 55, it's just going to go off on its alarm. In my opinion, it should be set to 40, 45 from the factory. That would make sense to me, but again, I don't know everything. Maybe I'm missing something. If anybody out there watching has more experience with that unit, knows a little bit more, please shoot me an email, leave a comment. I'd love to learn something about that unit. And then, of course, the other problem we had was our airflow issue. Our air was spending too much time going through the evaporator, and the slower the air goes through the evaporator, the more time the air is exposed to the evaporator, the more heat it can absorb out of the air. So that's why we had such low supply air temperatures. And that was because our blower motor pulley was opened up all the way. So essentially when you open up that pulley all the way, you're making it smaller. And that motor has to rotate more times to try to get the amount of airflow you need. So we just closed it down, basically made it bigger, and which it takes less rotations to get the motor or get the blower to spin around more times to get more air flowing through the evaporator, basically. And yeah, that's really all we had on that unit. Other than that, everything else was running great when I left. After we restored airflow, when I left, we had a supply temperature closer to 49 or 50. Everything else on that unit was within tolerance from the factory. So I hope you guys enjoy that. Hope you learned a little bit of something maybe. I'm just trying to pass along the little bit of knowledge and experience I've gained over the years, all right? So if you did like it, shoot me a comment and subscribe, all right? Like and subscribe, guys. We'll see you on the next one. Hey guys, so we got an interesting one today. I have this old York unit, and what we have going on is when this unit receives a call to cool from the energy management company's communication board, it trips our resettable fuse, the little 3.2 amp popper that's in line with this transformer. Now right now I just have the energy management communication board bypassed. I'm just jumpering out, putting a signal right from red to Y1, and I just wanted to do a quick amp draw just to make sure none of my contactors, none of my relays were pulling excessive amounts of amps, causing that little resettable popper to pop. So it appears that whatever is our issue most likely is between our communication board and this unit's main control board. So because right now I'm running in cool mode. Let's check our supply temp real quick. Yeah, we got a supply temp of 53.9 right now. Our condenser looks nice and clean, but you know, there's only one way to tell. Let's get our airflow device on there. Decent airflow, not too terrible. Now we did clean this condensing coil. That's why it is so clean. I know it's clean because we cleaned it. See, there's a little bit of a repair done there. Looks like a little pinhole leak was fixed at one point in time. But mechanical cooling doesn't seem to be our issue. We have a low voltage short somewhere. So let me turn the camera off, guys. I'm going to pull some panels apart and then call our energy management company, have them initiate a call for cool, or maybe I can just bypass right from their board and initiate a call for cool myself. So when I get everything set up, I'll bring you guys back, all right? I have verified a call for cooling from my energy management communication panel. I'm about to power this thing on and see if this little fuse will pop on us now, because everything else in the machine seems to function fine when I bypass the communication board. So I believe we have a problem with our communication board, but let's power it on, see if this pops, and we'll go from there. Oh, look at that. As you can tell, we just about immediately popped as soon as we got that call for cool from the communication panel. So we're gonna have to investigate that panel and the wiring going from that panel into our unit here, because that seems to be our issue. All right, let me start pulling some panels off and I'll bring you along as soon as I can. Now, over the years, I've had a lot of low voltage short problems, and they're usually really hard to find. Most of them are anyway, only because the wires are so tiny and all it takes is just a little bit of a rub out to create that short to ground. But here is what I found. If we look over here on our energy management board, you'll see this blue wire. I don't know if you can see that, but that blue wire is connected to common on this energy management board, and our Y1, which is disconnected because our fuse was popping, of course, normally goes to Y1. All right, now remember that. And I did inspect this wiring, the bundle, all this wiring going through the chassis. There's nothing rubbing through. That's perfectly fine. But if you come over here to our control board, you'll notice our yellow wire comes down here, goes right into our common for some reason, and our blue wire, which again is wired into common over on our energy management board, goes to Y1 over here. So it's a real simple fix. We just need to switch our blue and our yellow over here on the energy management board, because right now whenever we get a call for cool, it's sending it straight to common through this yellow wire. So, pretty simple fix, guys. I'm going to swap those wires around, double check my voltages, amp draws, supply temps, and then we're going to get out of here, all right? Just a quick little one for today, guys. Hope you enjoy. Like and subscribe. All right, guys, so tonight we are on an after-hours no AC call in a very hot kitchen at a very busy restaurant. So my initial inspection, I found the thermostat display was dead. I haven't got any further than that. Thermostat display is dead. Disconnect is on. Our breaker downstairs is not tripped. So, first thing I'm going to do is pull that panel open and start taking some voltage readings, alright? I got my front panel off, and if you'll notice, I haven't shut my disconnect off just yet. Now that's important because I don't want to disturb anything at this point because I don't know what's going on yet. If there was any fault codes flashing or something, they would be lost. If I just turn that off, start pulling panels apart, and then I flip it back on, I run the risk of losing any sort of fault code, possibly resetting something. Looks like, I think I've already seen our issue, of course. Right there, our little popper is tripped, so it looks like we're having some sort of low voltage issue, guys. So we'll have to delve into this a little bit more and see what's going on here, because that's a coincidence. I just had another one earlier today that it was a low voltage short. So, all right, guys, let me put this camera down and see if I can see anything. Get my meter out, and I'll bring you along in just a minute. I reset our little popper. Before I did so, I did visually inspect everything. I didn't see anything obvious. No low voltage wiring touching the chassis at all. The only thing I did notice was one of our contactors, that wire right there, kind of looks like it got warm a bit, so we'll have to address that in just a little bit. But I still don't have any cooling. I haven't verified if I have a signal for cooling yet, so kind of waiting to see if anything happens here. Here's what we got going on, guys. So I got tired of waiting for my thermostat to initiate a call for cool because the area where the thermostat is, I guess, is a little too cool. So anyway, I installed a jumper from my red to my Y1, and immediately when I did that, the fuse on that control board popped. And then I went over and after I found that, I went over and I noticed that somebody had replaced it with a 10 amp fuse. It's supposed to be a 5 amp fuse. Now that's probably no real big deal, but of course when I go to replace that, I'm going to put the proper size fuse in there. So I have my little 5 amp popper on here, just hooked right up to the board there, just for testing purposes. So I'm going to power it back on. We should immediately go into cool mode, or our popper will pop if we still have a short. All right. Well, it looks like we still have a short somewhere. So we are going to have to look a little bit harder for this one. I think I'm going to disconnect my jumper first, reset my popper, see what happens. All right, my indoor blower came on. I got 26 volts on my red. I don't have a call for cool yet, but I'm guessing somewhere that is our issue, because whenever I do jumper that thermostat and initiate a call for cool, my little fuse over there trips. And to be honest, I don't know if when I jumpered that, if that's when the fuse blew, or if it was like that already. I just maybe coincidentally thought that I caused the problem, but I'm starting to believe, since the system was already dead and my thermostat was dead downstairs, that it was probably like that when I got here. So, all right, well, let me put this camera down and start doing some digging, and I'll bring you along as soon as I can. All right, guys? What I've done so far is I removed the yellow wire for my stage 2 cooling, and I bypassed the thermostat in stage 1. And I did that without having any sort of issue. So what I'm going to do is I'm going to jumper now to the stage 2 wire and see what kind of results we get. Chances are our little popper will pop. And if that's the case, then I'm somewhat certain our issue is in our stage 2 cooling. Well, didn't really get the results I was expecting out of that test. I'm in stage 2 cooling right now. My little popper over there didn't pop. The popper over here is fine. So whatever we have going on, I'll bet you we have maybe a slight little rub out that's just kind of barely touching something. Alright, well, let me get in there a little bit closer and see if I can inspect some of this wiring. Well, it took a little bit of digging, but after that last failed attempt of getting my little popper to pop, after the first time it popped, I got to looking around, and just right over here, I just happened to notice a little burn spot right there. And then I flip this wire around, and right there you'll see where it has, my camera will focus on that, it is basically rubbed through, and that's where it was shorting out at. See, now with something like this where it's held in a certain position, but it was probably bouncing around from the vibration of the condensing fan motors, you know, whatever other vibrations this thing, when the indoor blower motor would come on, it would probably shift a little bit. So the first time, it was probably, my first initial test, it was probably laying right on that pipe. And then maybe during my second test, some of the vibration knocked it loose. And then that's why my popper didn't pop. But yeah, the low voltage shorts, you gotta kind of be really aware of little stuff like that, because it just takes the littlest, tiniest rub out on the littlest, tiniest wire in the I don't know, the most obscene place to create this sort of problem. So I'm going to go ahead, cut and splice that wire, and then we're going to go through and basically recommission the system. I'm going to go downstairs, adjust my thermostat, replace that fuse. Well, no, I take that back. I'm going to splice that wire, adjust my thermostat, make sure everything functions fine, and then when I know I have no more issues, I'll replace that fuse, because I don't want to leave a pile of 5-amp fuses up here that are all burned out. So, alrighty, well, let me get that taken care of, and I'll bring you along when we're done. Here's your tip of the day, guys. If you can see in there, what I've done is I've taken one zip tie and put it around this metal loop that's on the compressor, and then I've taken another zip tie, threaded it through that first zip tie to hold my wires basically to that second zip tie. So this way, my wires are not directly in contact with this piece of metal on the compressor. Because even if they're zipped down to that piece of metal, there will be a little bit of vibration, and you still run the risk of eventually them rubbing out and shorting out, as it did on this copper pipe over here. So that's not my original idea. I believe I got that from one of Chris Stevens' videos, from HVACR videos. So if you're not subscribed to him, what is wrong with you? You need to go over there and subscribe right now. Some of the best stuff on the web. Alright? So that's your tip of the day, guys. I'm going to get back to getting everything set up so we can turn this thing on and take some supply temps. Looks like we got kind of lucky tonight, guys. That was our only issue that I found. I just went downstairs, turned my thermostat down to 72. Our temperature in the office area, stock room, was about 74. Compressor amps are 10. Right over here, I was pulling about 9.8. No, 10.8, sorry. Our indoor blower, we're pulling 4. I haven't replaced that fuse yet. I'm going to power it down as soon as I get as soon as I get supply temps recorded, let's go over here, see what our supply temps are at. That's pretty good for a 21-year-old unit. 52 with a 78-degree return, so yeah, this unit's kicking butt. But alright guys, that does it for tonight. Hope you enjoy, like and subscribe, and I will see you on the next one. Alright guys, so today we got a walk-in cooler, low profile coil, and it's holding steady about 50 degrees. So I just got here, just got this ladder out, just got my probe up there, and we are going to let that run for a little bit. Now this right here is basically our return. It pulls air in this way and then blows it out the side. That's what these low profile coils do. So I'm testing my air at my return. I don't know if it's picking up on camera, but there's a little bit of a drip going on over there. I don't know what that's from yet. I did check our drain. Our drain is nice and clear. So I think my next step is going to be check my thermostats, make sure it's set properly, and then I'm actually going to take this whole coil and drop it down, make sure everything's nice and clean on the inside. Alright guys, let me give you a quick little tour here. Up right there you'll see our little TXV with our two little distribution lines going to either side of our evaporator coil. There's our little liquid line solenoid up there. Yes, that is an externally equalized TXV as well. The thing that I immediately noticed is weird. We got a little bit of ice building up over here. Not really sure what's causing that yet. All our fans are spinning the right way. Our coil's not dirty. Our airflow seems to be correct. So I'm not sure if maybe we just had some standing water that was building up in this evaporator coil, causing that to freeze up. We'll have to look into that a little bit further. If you'll notice over there, one of my wires pulled off because somehow it wasn't long enough, and I dropped this evaporator cover and just kind of pulled it apart, so I'll have to address that in a few minutes here. So nothing alarming at this point yet, guys. So we just gotta keep on digging. All right, I got my evaporator fans wired back in there. I secured it a little bit better. Also went through here, just made sure all my wiring was nice and tight right up in there. No loose wiring or anything like that. I believe I figured out the reason why we were dripping around the two middle fans in the center there. If you look very closely right there, there's a middle post that the evaporator panel should have been screwed to. It was only screwed to this side and then the far side. And I believe what was happening was that middle section was sagging a little bit. It's not a very deep pan, and there is a grade to it, of course, that leads over to that drain. And I think with that middle screw being out, we didn't have enough grade to drain all the water. I believe a little bit of it was puddling up around the middle fans there. So when I put this back together, I'll obviously put that screw back in there. And that could have been the reason why we had water puddling up, a little bit of water freezing onto our coil. But it doesn't really explain our 46-degree return air temperature on this unit just yet. We still got to get upstairs, get some eyes on the condenser. Now that I know my airflow through my evaporator is okay, we'll get this put back together and, like I said, get up on the roof. Just wanted to point this out real quick, guys. This thermostat right here has the sensing bulb mounted to the side. Now, obviously our airflow blows up the side, so that makes this our return air. So the sensing bulb should be in our return airstream, which would be right here. It looks like it was at one point in time, but for whatever reason it was moved. So before I head on upstairs, I'm going to move that sensing bulb right over here, and then we'll get up there and get some eyes on our condenser. Alright, real quick, I just wanted to show you the grade on this drain pan. And if you follow the lines on the evaporator, you can kind of tell there's just an ever so slight pitch to the far end down there where our drain is. So we got that all back in shape. I'm going to tighten that middle screw down and get upstairs. We're looking at our condensing coil, our condensing unit for that walk-in cooler. So far I haven't seen anything obvious. When I got up here it was running. Then it sounded like it pumped down and shut off, which is kind of odd because when I was leaving the box it was about 50 degrees still in there. So I can't imagine that by the time it took me to get from downstairs, climb up the ladder, drag all my stuff up here, that it actually reached temp and shut off. But maybe. We'll have to revisit that in just a little bit. I'm going to go downstairs and make sure that thermostat is set properly. But as you can see, our condensing coil is nice and clean. A little bit of back story to this unit. Friday we were here to repair this unit because it was warm again, and what we found Friday night was the evaporator coil was a complete block of ice. And so I got the coil thawed out, and what I found was 3 out of the 4 evaporator fan blades were flipped upside down. So the scoop on the fan blade was facing the wrong direction, so it wasn't properly scooping the air and pushing it up through the sides of the evaporator coil, right? So it was obviously moving some air, but with the scoop being backwards like that, it was pushing the air up into the evaporator coil, probably tumbling it around a little bit. Obviously it's not an ideal situation, so we were probably moving maybe 70% of the air through the actual coil. So we thawed that out, flipped the blades around, and the following day we had another issue where it was starting to creep up in temperature again. So we had another technician come out here. He cleaned our condensing coil, double checked everything, and didn't find a whole lot wrong. The thermostat was wired improperly. That was taken care of. That was actually on me. I had put the common wire in the wrong spot, unfortunately. But in my defense, it was 11 o'clock at night after a 15-hour day. Not making excuses, but it happens. I'm humble enough to admit I made that mistake. So far, I haven't found anything wrong except the sensing bulb being placed up on the side of the coil like that, down at the evaporator coil, of course. Not being in the return like that, I feel that sensing bulb isn't obviously going to read an accurate temperature. It might actually read colder, and since the metal side is so close to the actual evaporator coil, and it's going to conduct a little bit of cold from the actual copper plating to that stainless steel plating, I feel that sensing bulb probably sensed a colder temperature than what it actually was. So that's why the box was at about 50 and the unit thought it was at about 38, 40 and shut off. But right now that's just my idea. I haven't found a smoking gun yet, if you will. So, all right, well, let me go downstairs, double check that thermostat, make sure we're set properly. Then I'm going to come back upstairs. I think I want to attach my gauges just to be absolutely sure we don't have any sort of other issues. I want to get a good accurate read on our superheat subcooling, everything I can get at this point to make sure this unit's handled properly. All right, guys. So let me go check out that thermostat downstairs. Now, our thermostat seems to be acting somewhat erratic. When I got down here, my little probe was about 49, 50 degrees, and we were off until I bumped the minimum maximum differential on this thermostat. As soon as I just kind of bumped it, it came back on. So I don't know what's going on with that. That's a brand new thermostat as of Friday. Now, I bumped it, and we're still cooling like we should be. Let me show you here. We have no voltage differential, no potential difference between these two holes right there. So we're still cooling. Well, actually, no, I take that back. We just stopped cooling. As you can tell, we are at 45 degrees, and we're set to about 35 degrees. See? Now, For the guys just starting out, I know that we are open because now we have a potential difference across there. When I had 0, that switch was closed. That's why I read no potential difference across these two leads. So I think since I now question that thermostat, I'm just going to swap it out. I don't really trust it at this point, so I'm going to swap it out, and then we're going to continue digging into this thing. All right, guys? We got a new thermostat in place. We are open. That's why we have 208 volts across it. We are at 51 degrees. That means once I crank this dial right to a hair below 50, we should hear our solenoid click in place. There it is. So this one already seems to be a little bit more accurate, but I'm going to stand here on this ladder and watch it. We'll just make sure that it is closed. Yep. No potential difference across our leads, so we are closed. All right. Now I'm going to sit back and watch. All right, our unit's running. New thermostat is on, so we're going to get our gauges hooked up. And as I always do, I'm going to start with the high side, and I'm going to purge my gauges using the high side. All right, my high side is on. I close these two ports right here. I open up my gauges. This way I'm feeding refrigerant through my high side, through my gauges into my little hoses here. Now I'm going to open my high side right here. I'm just going to bleed a little bit of refrigerant through here. There we go. Now we are purged. Now, most moisture or anything else that would have been inside my gauges is now out. I can't get on my low side because I apparently need a T. All right. Let me run downstairs and grab a tea for this real quick and show you what I'm talking about right here. I don't know if you can still hear me, but see, right back here, I can't get on there because it's too close to our liquid line. All right, let me go grab a tea. All right, guys, here's our tea. I'm going to connect it to my low side. And then we can get our low side pressure. Our refrigerant over to 404. All right, R404. So far, we're looking pretty good.
It's about 80 degrees out here. I'm going to get a more accurate temperature in a second here. I got a 28 degree evaporator, 111 degree condensing temperature. '24 superheat, which is good. My subcooling's not coming through for some reason. Just moved my liquid line probe to the other side of my receiver. Give that a few minutes to stabilize, see what our subcooling is. Alright, I got a 24 degree superheat. It says I have about 2 degrees of subcooling, which is not accurate, of course. I need to have around 10. I'd settle for 5 even, but I prefer 10. Now the other thing I did is I didn't clean that pipe that I connected to, so that could also be an issue. And it looks like we're pumping down right now. We must have achieved our thermostat setting. So while we're at it, let's see what it pumps down to, all right? I think 5 is, it's a little high. I would prefer that to pump down to closer to 2. Alright. Now we are holding, you can see that right there, we're holding our low side at 6 pounds, so it's not moving a whole lot. That means our compressor valves must not be leaking by at all, which is good. We just need to watch the unit cycle one more time and make sure that my adjustment is a little bit closer to 2 for the cutout pressure. Our cut-in pressure on this one is about 30. So, alright guys, well I'm going to go downstairs and check the temperature inside of our box and see how it's going.
Alright, we just got down here to our box. Our return air is 44. It only took me a few minutes to get here and open that door, so we should have been a little closer to 38, 40. I'm going to go ahead and lower that a little bit more. I would have preferred to put like a Ranco digital control on there. This particular customer wants the mechanical control. Looks like we just kicked back on. And our thermostat went off. Now, from the time it took me to get downstairs, or get from upstairs to downstairs, I don't know if anybody was walking in and out of here, but I can't imagine that that would have made that big of a difference. Just a little bit of time. So we just kicked back on, and I'm going to stick around and see exactly what it shuts off at.
We're back up on the roof, watching our pressures. I left the thermostat set where it was so I can watch it pump down and see what our cutout temperature is. Our subcooling's still pretty low. I checked our sight glass. It's nice and full. I might add a little bit of R404 just to get our subcooling up there a little bit. Now we should be pumping down any minute now. Here we are. It looks like we are pumping down. Let's see what our cutout pressure is. That'll be this number right over here. I want to see that number get down to about 2. All right, 0 is not too bad. That's a little too low for me, though. I'm going to adjust it just a little bit. All right. And now I am back downstairs in the box. So, we're at 43. I just turned the thermostat down to 30 because I was still cycling off about 45, 46 degrees. Now, I'm starting to believe that the other thermostat wasn't bad necessarily, but I've always known that these mechanical thermostats are a little bit touchy, a little bit flaky, where if you set it on this number, that's not the exact number that it shuts off at. And I wonder if the body of this thermostat being so close to the coil is actually affecting the temperature that it shuts off at. That's my theory anyway. But we're down to 30 now, so by my calculations, that should shut us off at about 36 or 38, roughly. So, we'll see. We'll let it run for a little while, and we'll come back when she shuts off, all right, and see what temperature we're at. And we're back at the roof. All right, we're pumping down. I'm not sure what my box temperature is right now, but remember we pumped down to 0 last time, and I think it was about 9 before that. So fingers crossed, we were closer to, I would even settle for upwards of 5, between 2 and 5. Yeah, all right, I can live with that. And you'll notice our subcooling was much better this time too. The subcooling, I didn't do anything as far as the charge. I just relocated my liquid line temperature probe, my temperature clamp. I just put it over here. I kind of felt like since I had the top on the box, and the reason I had the top on this condensing unit was because of the rain, and I felt like all the heat coming off the condenser was affecting the temperature clamp's reading, because I had it right around the dryer. I was trying to get it about 6 inches away from the condensing coil itself, which would have put it around the top of that dryer, which is okay, but like I said, I was getting just a ton of heat pouring off that condensing unit, or the condensing coil rather, just pouring right onto that temperature probe, that temperature clamp, and like I said, I think that was skewing my measurement. So I'm gonna run downstairs, check that box temp, and see where we stand, all right? Alright, let's check our return temperature. Looks like our thermostat cover fell down. It was at about 39, but it is rising. So I'm going to turn that down just a touch more. Actually, I think what I'm going to do for an even more accurate test, I'm going to rig up a temperature probe from inside here, and then we'll run it outside, measure it from outside. Alright, so I have the probe for my fancy thermostat here. I have that sitting up next to my sensing bulb, and we're reading 37.2 return air temperature. So we are doing pretty good. And that is with the thermostat set to 28 degrees. So, and again, that goes back to, I believe, that thermostat body being mounted so close to the evaporative coil itself is actually skewing its ability to maintain a proper temperature. So I think that's why I have to set it a little bit colder. It's because the body of the thermostat is actually so cold. So I think we're going to leave it at about 28 degrees. I'm going to put a little mark on there so anybody else who comes in knows that that thermostat is designed for an offset, or that I have it set up for an offset of about 10 degrees. But perhaps one day my customer will allow me to put a KE2 or a Ranco controller in here. That's what I recommended, but like I said before, they're just not keen on that idea, so I'm not going to force them. But we're at 37 degrees, guys, so we're good to go. All right, like and subscribe. We'll see you on the next one. All right, guys, I hope you can hear me well. It's kind of windy today, but today we're working on something I don't see too often. I got a 30-ton package unit here, train of course, and our problem is a very warm kitchen. Now this system uses a zone sensor, which is in the kitchen, and our thermostat says, according to that zone sensor, our space is 64 degrees, which obviously it's not. So the first thing I'm going to do is I want to make sure that this unit is mechanically sound, that there's no issues with it, and then we will address the zone sensing issue. So let's start pulling some panels off. This thing is massive compared to what I'm used to seeing. All right, let's get a quick look at our microchannel coil here. Let's see if we can pick that up on camera. It is really, really clean. I don't know if it's translating well on camera. You can kind of see through it. But yeah, you can see all the way through this coil. So this coil is nice and clean. Then we're going to come over here to our ginormous evaporator. Now, I'm about 6 foot. This unit's got to be about 6.5 foot tall. I'm just going to step right inside here to get out of the wind. Yeah, this is it's a big old unit right here. Now, I'm not actually looking for a problem inside here, but I'm a curious guy by nature, so whenever I see a unit this big, I like to explore a little bit. No harm, no foul. Worst thing that could happen is I become a little bit of a better technician from looking around out here. So I'm sure you can hear the wind out here. It's a really, really windy day out today. And I took that door off because I was tired of getting hit in the face with it. Now, I don't know if this is a train thing. It doesn't look like it's from the factory, so I don't know if this is a train thing or maybe an on-site maintenance guy put that on there, but apparently it was there to, I guess, maybe hold the doors open or something. But it does no good, especially on windy days like today. So, long story short, it takes 30 seconds to pop that door off, and you don't get hit in the face anymore. So let's start with the simple stuff first. Let's check, see if we even have a call for Y1. I don't think we do, because our zone sensor is telling our thermostat that it's 64 degrees in our kitchen. There we go. We have no voltage, and that is from Y1 to common. I'd like to thank you guys out there who were telling me about that. I guess just used to doing Y1 to ground, but common is a much better way to measure your voltages. Now let's do red to common. I do have control voltage, but as I thought, I'm not getting it from the thermostat. So what I'm going to do is I'm going to bypass that. I'm just going to kick it into probably second stage cooling, get a supply temp, get a couple readings, and then we'll go from there. But I believe our problem is that zone sensor downstairs. So, all right, let me bypass this, guys, and I will get back to you in just a minute. All right, here's our tip of the day, guys. For all you new guys out there, this is probably obvious, but just in case it's not obvious, when you're working on a customer's piece of equipment, clean up after yourself. Don't leave cigarette butts in your machine, old zip ties, terminal ends. It takes 11 seconds to throw this stuff away. Don't be lazy. Chances are our customer isn't going to come up here and inspect it, but one day they might, and they're going to know that you did it. Or even if, for example, if I leave this here, and tomorrow my customer comes up here, they're going to think I left it this way. So I'm going to clean all this stuff out of here because I don't want to have the reputation of the guy who just leaves garbage inside the package units, all right? That's your tip of the day, guys. Today is a very adventurous day for me. So I happen to be walking around, and I noticed this Copeland condensing unit over here. And if you look closely right there, you'll see we have our liquid line right here, our suction line, and then also another suction line coming off the main suction line. Now, I've never seen one of these in the wild before, so if anybody out there has seen one of these, enlighten me.
but I did recently read about them in Commercial Refrigeration for Air Conditioning Technicians by Dick Wurz. The best book on the market, in my humble opinion. So, if I remember correctly, when it's at full capacity, when they say, I don't know how many coolers or how many racks or whatever are hooked up to this system, I'm not familiar with that, but from what I read, if I remember correctly, is that when it's at full capacity and say all coolers are calling for cooling, it uses both these suction lines. Now at lower capacity, say only one cooler needs to cool off. The other suction line, this larger suction line down at the bottom inside the cooler, will have a reverse trap on it, and that reverse trap will fill up with oil, and then it will only suck our gas up through this other suction line. So when that other trap fills up with oil, it kind of blocks it off, and then it only sucks oil, or excuse me, only sucks our refrigerant up and through this suction line. So it's kind of neat to see one of those in the wild. Come over here. We got a bunch of crazy stuff on this one. Huh. Looks like we got some sort of, I don't know if you guys can see it very well, but looks like we have a TXV right there. I'm assuming that's probably for capacity control. Looks like right back there we have what appears to be an automatic expansion valve, maybe. Interesting. Well, guys, if anybody out there knows exactly what I'm looking at, please let me know. I'm gonna go home and do a little bit of research on this, because that's pretty cool. Like I said, I've never seen one of these in the wild, so it's new to me. Anyway, back at the task at hand. I have our unit bypassed in stage 2 cooling. Let's see, looks like we got some contactors going. I don't hear our compressors running. Might have to pull this bottom panel off and see what's going on over there. We got condenser fan action, but no compressors yet. Alright guys, let me dig into this, and when I figure out something, I'll bring it back. We're in stage 2 cooling now. That is to our condenser motors, 10 amps. That, I believe, is our stage 1 compressor. It came on first, 15 amps. Stage 2, 14 amps. On this, I believe it's a 30-ton unit. Let's check our supply temp over here. On 58.9 and dropping. Yeah, I don't think we have any sort of mechanical issue with this unit. Like I said, I believe our issue is just that zone sensor downstairs, so I'm going to try to get a little bit of footage downstairs of that zone sensor if I can. At least it'll be less windy. So, alright guys, well, let me see what the supply temperature drops down to. I want to see it get down below 55, and then we'll go downstairs and start looking at that zone sensor. Here's our wall of thermostats. We are looking at number 4. So, our zone sensor says it's 70. I did just pull that stat off the wall. It said 64 before I pulled it off, put it back on there for some apparent reason. I'm not sure what that did, but wanted to make sure our, see, there's our zone sensor, S1, S1. Now I ohmed that out. It was 9.6 across that zone sensor, which is comparable to the other zones. So we'll get an actual temperature near that zone sensor. All right, here's our zone sensor. my probe says 84, if that zone sensor is correct. At the stat it says 64. At one point it said 68, and then it also said 70. Now that zone sensor has been replaced, so I'm going to pop the cover off just to make sure the wiring is set up properly. But we're definitely not reading accurate temperatures. Here's my idea. I'm going to tie my two zone sensor wires. I'm going to tie them together, and I'm going to go back to that zone sensor and test for continuity. I should have continuity over there if those wires are either broken or if they're correct at all. Keep in mind my rooftop unit is off, so I'm at no risk of damaging any low voltage circuitry upstairs. So let me go over to my zone sensor and check for continuity. Alright, so as you can see, we're now reading 80 degrees, so we're now actually reading our zone sensor. Now what had happened was somebody had programmed the zone sensor to read at the thermostat body instead of the zone sensor, so I just went through and reprogrammed it, so now we're actually reading at the zone sensor instead of the thermostat body. So I believe we're all set. I'm going to wait around, watch this thing kick into cooling, and we'll see what happens.
Alright guys, so as you can see behind me, there's a storm coming, so it's just about time to get out of here. It looks like all we had downstairs was a simple programming issue. They had another company out a couple days ago replacing that zone sensor because they determined that the zone sensor was bad. I think that maybe they replaced the zone sensor without checking the programming of that unit, possibly. How it got screwed up, I really have no idea. But as you've seen, after I programmed it to actually read that zone sensor, we were reading correctly. I just came up here on the roof and I powered on our ginormous package unit here. We're just waiting for it to kick on. With these Trane, there is a delay, an anti-short cycling delay of about 2 minutes or so, and then it'll probably want to go through the economizer, see if it's going to kick into safe when fueling. But I think I just heard our condensers come on, so we'll give it about 5 or 10 minutes, guys, and I'm going to re-record my after repair supply temperatures. All right. I hope you guys enjoyed the video. Any questions, feel free. Shoot me some comments, emails. I'm always open for suggestions, tips, advice. Anything you see I'm doing wrong, let me know. I'm not perfect. I just try to be. It's a journey. So, anyway, guys, like and subscribe. See you on the next one, all right?
All right, today, guys, our complaint is a very, very noisy rooftop unit. I just walked around the store. I didn't hear it, so I'm assuming our unit is off for some reason. Probably due to something breaking or blowing up or something happening inside that machine. So we're gonna head up on this ladder here and see if we can't find this problem, all right? Follow me. Probably dizzy after that, aren't you? But that's HVAC in real life is what that is, guys. So let's go explore this roof and see if we can't find our issue, all right? Now, as I said on our trip up here, I couldn't hear the noise inside the location, so
we're just going to walk around the rooftop here, make sure all these blowers are on, see if we can't figure out the noise. Chances are it's just a belt squealing. This one's running. Belt looks okay. No abnormal noises on this machine. Now you'll find this from time to time when you go into locations where maybe the night shift put the work order in but didn't tell anybody on the morning shift. So nobody knows why I'm here really, except for a vague description in my notes. So this one, this one's got a little bit of a squeal, not necessarily a squeal. This one's got a little bit of an abnormal noise to it. I'll bet you it's this unit. So we're going to revisit that one in a few minutes. The vague description I was given in my notes said it was coming from a certain aisle. So I have at least that to go on. Alright. This little guy's direct drive, so that's not our issue. Our condensing fan motor was just going, so that was not making any noise, so chances are this little guy right here probably also direct drive. No, I was wrong. That one's got a little bit of a noise to it. And then the other thing I noticed right here, we have air coming out of our inducer. So our inducer is on. So chances are we're locked out on some kind of code. So let's open up that panel and see what kind of code we're locked out on. This particular unit, this little guy, is a belt driven. There was a little bit of squeaking noise coming from the belt. Our inducer motor is on for some reason. Our compressor is running as well as our inducer, which is weird. Condensing motor is also running. Let's see what our Prodigy tells us. Heat 1. Oops, wrong button. I'm just double checking the alarms. They did display the alarms on the initial screen. So economizing when it should not. That's apparently the only alarm. So I'm going to clear the alarm history. Make sure it's cleared. Alarm history empty. Then what I'm going to do is I'm going to reset the machine, see if our inducer comes back on. It could just be a simple stuck relay for our inducer motor. Alright, so immediately when I powered this back on, my inducer came right back on. So we're going to let this start up and see if we have any more alarms. Normally when our inducer comes on like that, we have a a temperature limit alarm, a rollout switch alarm, some sort of thermal limit alarm. And here it got pretty cold last night, down to about 60, 65. So our heat probably came on. Let's go down to what right here. History, alarms. Yeah, see, so I'm getting no alarms. Nothing that shows thermal limit switch, rollout switch. Nothing explaining why our inducer comes on. So we probably just have an ice cube relay that's stuck. So, all right, well, let me dig into this, guys, and check a few things out, and I'll bring you back around in just a minute. All right, guys, so here's where we stand. I'm going to bring you along through my confusion here. So this is our relay, our ice cube relay that powers our inducer draft motor. Now, as you can tell, those relay contacts are not welded shut like I thought they were. That is its normal position. This gray wire goes up to this top terminal. That is normally closed, as you will see right here on our schematic. 3 and 9, 7 and 1, and just to help me think it through, I drew this little diagram. So now when I power this unit on, I'm still getting inducer draft action. I'm not exactly sure why yet, because if we look at this, my first thought was I was getting power through 7 and 1 and 3 and 9, and our inducer motor was just in its low setting because this is a 2-stage inducer draft motor. In order for that to happen, I would have to have K13-1 up here, which is normally opened, which feeds this relay. I would have to have that closed. So if I come over here to this relay right here, this terminal right here is our K13-1 7 and 4 relay. And those are open. So I'm not 100% sure yet what's going on there. When I pull this relay is open. But let me back up here a second. That relay, these two contacts up here, these are closed. So right here, these two contacts right here that I'm testing, those ones need to close in order to feed my inducer draft relay. However, if we go over here and I test them at this connector, not really easy to do with one hand. Alright, so they're not closed. So I don't have any continuity through this set of wires or that relay. So I don't know, I honestly don't know what is feeding this relay just yet. Because as far as I can tell, unless I'm missing something, as far as I can tell, this relay right here needs to close in order to feed the relay that controls our inducer draft motor. Now, at the risk of looking dumb, I wanted to take you through this troubleshooting process because you might learn something. I know I'm going to learn something as soon as I figure out where that power is coming from. And let me do a little bit more digging, guys, and I'll bring you back in just a minute. Alright, we're back to this confusing process. Now this is such a simple relay, guys. I almost feel like I'm overthinking it at this point. I feel like it's something so small and so minute that I've
just developed tunnel vision, and now I can't seem to see the easy problem that's in front of me. So we're still getting power to our inducer somehow. Now I know this white side, our common side, obviously L2 always has power. So in order for this motor to run, we need to complete the circuit. We need to get 208 to that motor through one of these lines. Now if we trace it up through our low side, this side is always closed, our normally closed side, but we can't complete a circuit because terminals between 6 and 9 are open, which I verified. Same on this side. We could possibly complete a circuit through 7 and 1, our normally closed side, but in order to do that, we would have to have the terminals on the K13 relay just above it, 7 and 4, those would have to be closed, and they are not. I even disconnected the wires, and I'm still somehow getting a complete circuit to power that motor. So I'm not sure, but if it is something simple that I'm missing, I'm sure somebody's gonna let me know in the comments. They'll probably give me a thumbs down or a sad emoji. But I'm gonna keep on digging, and hopefully when I learn something, somebody else out there is gonna learn something too, because I am gonna learn this the hard way, it looks like. Real quick before I get into some more digging here, I just wanted to point this out. Right here, this is all of our limit switches, thermal limit switches, our rollout switches. If one of these were to open, they would send a signal to our control board here, our A55 control board, and that control board would send a control signal out to our K13 relay, which is this top relay right here. And when that relay would close, it would energize our inducer motor. Now remember, this relay is not getting any control voltage. If we did have a thermal limit, I would get control voltage right there, as well as an alarm on my Prodigy board. So I don't have any control voltage, so that means this normally open circuit right here is not closed, which, as you can see right here, is our incoming power for our inducer motor. So I'm still completing a circuit somehow. I'm not exactly sure how yet. So let me get back to digging, and as soon as I get done learning this the hard way, I'll bring you back. Alright, so here's a quick update. After staring at this diagram for what seems to be 10 hours, I've verified literally everything I could possibly verify as far as my open and closed circuits on my K72 relay, which is this relay right here, as well as my K13 relay. Now this relay basically just controls high, low speed, and this relay needs to energize in order to get power to this relay. That's the only way it'll work. See right here, my K13 relay. So unless this is energized, I cannot complete a circuit through here. I don't have 208 on both sides, there's no complete circuit. So I called tech support, and thinking that I was going to sound like a complete moron. So I called tech support, explained to them my issue, and we basically, for the last 45 minutes, went through every single checking all these relays, the connection points. I swapped out the relays multiple times. I tested voltages. All my circuits that are normally closed are closed. The ones that are normally open are open. Neither one of these relays are ever energized because there's not a signal to heat. And again, my Prodigy board, which is off now because I have the unit off, my Prodigy board never threw any alarm. So long story short, even with the help of tech support, going through every single relay, every single wire, tracing voltages back and forth, testing the windings on the motor, I tested the windings on the motor to ground, thinking that maybe I was backfeeding through ground somehow. There is not a problem that we could identify. There's no connection point in that motor to ground, so that kind of canceled out that idea. I'm being fed proper power through my common wire. That was one of the things I was thinking, that's backfeeding. So I still think I'm backfeeding somewhere, and we must be miswired somewhere. Tech support had no idea really why, and the guy I was talking to was a pretty smart guy. He seemed to know his stuff. But after our conversation, he kind of recommended to call either Scooby-Doo or Ghostbusters, because somebody's playing a trick on us, or this machine is haunted. So I might go with the machine's haunted. So my next step is to start cutting zip ties, and I'm going to manually trace all the wiring coming from that motor up through, down there, up through all that mess, and up into the control section. Just making sure everything is landing properly, make sure that nobody somewhere in their head just randomly tied into the wiring. Yeah, so I'm not even sure. And I might even, just in case that doesn't lead to anything, if after I test all those wires, trace all those wires, don't find anything conclusive, I might just take that motor off and swap it with the unit over there, just to see if that changes anything. So what started off as a squeaky belt, which we still haven't even got to yet, what started off as a squeaky belt on this unit turned into the mystery of the century, I suppose. So, all right, well, let me start cutting some zip ties, guys, and I'm gonna start tracing this wiring out, and I'll bring it back when I come to a conclusion, or when I figure something else out. All right. I just got done cutting zip ties. I cut as few as I actually needed to, but I traced all of my wiring from that motor up into this relay, and even down to my white side where it connects to L2 right here. All the wiring goes straight from that motor to these relays. It's not wire nutted in some area. It doesn't appear to be tied into any other sort of power source. So I still have no idea. But like I said, I'm gonna take that motor out, and I'm gonna put it on the other unit way over yonder, and I'm gonna see if that problem follows us over there. And then obviously if it does, then I know our issue is in the motor. But I'm not real sure what to think yet. We're looking at two of our inducer motors. This inducer motor was off the unit way over there, the one that we were just checking all the wiring on with tech support. This is our haunted inducer motor. This inducer motor is the original inducer motor that went on this unit. This unit had no problems. So we're gonna power this thing on. And if you can hear that, we still have inducer action. Now let me repeat myself. This is our haunted inducer motor. This is the original inducer motor for this unit. And this is not a problem with this unit. So we somehow, turn this off here so you can hear me. So we somehow have an inducer motor that is backfeeding inside, and yeah, somehow getting power through itself. It's backfeeding through itself, because the only place we're getting power is through this common wire. Now I still don't know how it's even backfeeding, because all of our wiring going from this motor up through our relays back to line 1, this is line 2, all this wiring going up to line 1 goes through our relays, and our relays are closed. So, and I've already tested everything to ground. You know what, I think what I'm going to do is I'm going to actually take that motor, remove it, and set it on the ground and see if it still happens. That will tell me if we are indeed backfeeding through ground. Alright, let me get two hands on this. All my bolts are out of this inducer motor. I just pulled off just a drain cover off the roof here. It's plastic. So right now, with that inducer motor sitting on the plastic, it is obviously completely isolated. There's nothing going to ground. Now I'm going to turn it on, and if my theory is correct, it should not come on. We have no inducer action. That is amazing. I've never seen something like that before. All right, let's power this off. Put it back on here. I just got one screw holding it in place right now, but that should be enough. Actually, as a matter of fact, just to be absolutely sure, I'm going to put another one in on this side. And according to my calculations, it should come back on. And you have it. We have inducer action again. So somehow this motor is backfeeding through ground only when it's connected to ground. And that is powering our, I believe it's the low side, our low speed, because just judging by the sound and the amount of air coming out of there, it just seems to be our low side. All right, so what I'm gonna do is I'm gonna pull this motor off. I'm gonna stick it back in that machine. I'm not gonna mount it up or anything like that because obviously it doesn't work. So, and then I'm gonna quote a new one. I'll put that motor back in there. And then we're gonna get back to the task at hand. The reason why we actually showed up here was to address a squeaky belt situation. And looking at this unit and all the belt dust in there, I believe they all probably squeak a little bit. So I might just go around and quote all new belts for all of these units. Here we have our haunted inducer motor. I'm just gonna check all the wires to ground, to the chassis of the motor, and see if we have anything. Keep in mind, I did this with tech support on the phone. I didn't get anything at the time. I also did this before I called tech support and didn't get anything for some odd reason. Maybe I had a bad connection, I'm not sure. But immediately I have 1.2K ohms on my yellow wire, which is our low winding to ground, to the chassis. If you can see that, there's a little bit of a glare on the meter. As well as my red wire, the low winding, 1.2K ohms. Has some resistance on black, and looks like black and white. My meter's trying to read a capacitor. I have my capacitor disconnected, but long story short, somehow our motor is grounded internally, but it's not grounded in a way that would trip our breaker, which is somewhat confusing. I guess there must not be enough current going through it to actually trip the breaker. That's the only conclusion I can come to. But needless to say, we need to quote a new motor for the customer and come back and get it installed. So now let's go look at some belts. Real quick, I wanted to address this belt squeaking situation on these units. Some are worse than others, but they're all about the same. This particular customer quit doing our preventative maintenance program with us. As you can tell, that belt is almost 3 years old. It's squealing. There's a lot of belt dust on there. It's not aligned properly. I don't know if you can see that. It's skewed a little bit to the left. Also, this pulley looks to be opened up a little too far. I'd like to close that down and have the belt riding a little bit closer to the outer edge right there. Overall, though, it's not too bad for being almost 3 years old. What I'm going to do is quote to get a new belt on here along with a spare to keep inside here. And when they approve that, I'm going to take this belt off, clean this pulley, brush it, clean it, whatever I got to do, get it nice and clean, get all that old belt dust off there. Also on this spring tension, clean that and the blower pulley as well. And then once that's all cleaned up, we'll put our new belt on there, make sure it's aligned properly, and then we'll just record our amp draws. So just a quick recap, guys. That unit right over there, that one had a haunted inducer motor, something I've never seen before. So it was a learning experience for me. It was quite enjoyable. I hope you enjoyed it as well. If you guys have seen that before, shoot me a comment, shoot me an email, whatever. I'm curious to see if anybody else has come across that. I've been doing this for, I don't know, 12 years, and I've never seen something like that. I've seen plenty of them where they ground out and they'll short out, windings will burn up, breakers trip, and everything else like that. But I've never seen one that grounds out in such a way where it just runs in low speed all the time. So that's kind of crazy to me. But then as far as our squeaking noise, it wasn't really as bad as I thought.
All the belts are making noise on all of these units. All belts on here on all of these units are 2 and 3 years old. Like I said, they decided to stop their preventative maintenance program, and it shows. The belts are old, all the coils are dirty, filters are plugged. So, you know, they saved a little bit of money for 2 years not doing preventative maintenance, and now they have to pay a lot more to catch up. It's kind of backwards thinking in my opinion, but hey, to each their own. So anyway, guys, I hope you enjoy the video. Hope you learned something. Shoot me some comments, like and subscribe, and we'll see you on the next one, all right?
All right, today's project, we have an R404 Frankie double wide grill freezer. And the complaint was it's not getting cold whatsoever. Now when I got here, this unit was in the back room, not plugged in, so I haven't verified any symptoms myself yet, other than it is an R404 system and not an R290 like I initially expected. So first thing I'm going to do is double check that condensing coil, make sure we're clean, and then start pulling some panels off. Backside looks clear. Guess that's easier. Yeah, it's not too terrible. I can see through it, so at this point, it is kind of dirty, but at this point that's clean enough for me to at least verify symptoms other than a dirty condensing coil. So let's plug it in and see what happens. Alright, our compressor came on. Condenser fan is moving air. It's moving a good amount of air too. That coil is definitely just greasy and yucky though. That'll have to be cleaned out. Alright, so what I'm going to do next, I'm going to pull this panel off right here. Take all those screws out of the perimeter. I'm going to pull that out and start getting some amp draws of my compressor. I don't hear anything odd yet. It doesn't sound like it's short cycling. Compressor doesn't sound loud. There's no squealing, hissing, anything. I can even come up with an idea of what could be happening yet. So let me get this panel pulled off, see what I can see, and we'll bring it back in just a minute. So here we are at floor level, getting a bird's eye view of this condensing unit. Now, right now, you can see back here, but I'm just feeling the suction side of my compressor. The head of it is pretty cool. My discharge is nice and warm. Everything looks good. I don't see anything out of the ordinary. Sight glass here, though. Sight glass has some bubbles every once in a while. Now, I haven't confirmed the airflow in my evaporator yet, so that'll be our next step. So my bubbles will come on strong like this, then they kind of dwindle out to maybe one or two bubbles flashing through there, almost as if the TXV is hunting, just opening and closing rapidly. So let's go around front. We'll investigate this airflow inside the evaporator. Alright, so I just came around front here to check my airflow on my evaporator. And it appears, it appears we have reached set point We went from ambient temperature down to -5 in about 4 minutes. Now, right before it shut off, I was able to get inside here, and none of my evaporator fans were moving. So, I'm going to pop that cover off and get a better look inside there. You can kind of see them right up top there. Alright guys, let me get 2 hands on this real quick. Alright guys, here's a bird's eye view of our evaporator. Just got the cover off. You can tell our fans spin freely. I'm assuming they're just not getting voltage from our controller. I have not confirmed that yet. When we do, I'll just go directly to the controller and check right there. You can still see there's a little bit of frost on our suction line. Here is our liquid line, TXV evaporator inlet line. Still have a lot of frost build up inside of our evaporator coil right there. Real quick tip on these guys: when you're dealing with these thread setters on the stainless steel stuff, to keep from cross threading equipment like this, an old guy once told me, take the screw, put it in there, go counterclockwise till you hear it click, and then turn it in. When you hear it click, that means your thread's lined up. Just a tech tip of the day, guys. Alright, power's on at 32 degrees. My compressor is running. I have no action on my evaporator fans. I might be able to get in there and check that, I'm not sure. Since we're just dealing with 120, I can just go from one of those to ground, and at the very least see if I'm getting control voltage. Careful not to short anything out. I do not have any voltage, 0 voltage going to my evaporator fans. Now if you remember our sight glass flashing just a little bit ago, that was most likely due to not having airflow across our evaporator coil. The TXV is still trying to find its balance, to try to find its proper superheat. So it was probably just hunting, opening and closing, trying to find that balance. And it couldn't, since we have no airflow. So, let's pull out this controller and trace some voltage for those fans, alright? Alright guys, here's our controller. It says 24 degrees, and we're still dropping, even though I have the door open. And we still have no fans. Go right up there. No evaporator fans. Now, if we go right back here, you can kind of make sense. There's just a basic schematic on this. Terminal 1 right here is our evaporator fan. Terminal 2 is our compressor. And then number 3 is our incoming power. So let's go ahead and check a few things on this. Keep an eye on my meter, guys, and you'll see what I'm looking at. All right. So our incoming power, 119 volts. Our compressor circuit, 119 volts. Our condensing fan circuit, 0 volts. That's not real good. Alright, so let's power this off. Now in this particular setup, there are no safeties that would impede this controller from sending voltage to our condensing fan motor. So just as a test, what I'm going to do is I'm going to connect my, evaporator fan motors. I think I said condensing fan motors. What I'm going to do is I'm going to attach my evaporator fan wire over to my compressor wire, which, I mean, honestly, it should probably just be there anyway, but I digress. This will at least let me test this controller. This is a non-emergency situation. They don't really need this cooler. They have backups in place. That's why this one's sitting in the back, of course. So I probably won't leave this temporarily repaired like this. But I will jam this in there and see if we get evaporator fan action. Alright, that's a decent fix for now. Power's back on. Hold the power button down, and it should come on. A slight delay before our compressor comes on. The little blue snowflake means our compressor's on. You can tell up there we have evaporator fans going as well. Now they're not going to be able to do much since I have that panel off. They can't really pull air through that evaporator coil, so I'm going to turn that off, put the cover back on, and get that cover back on so I know we're pulling air up through our evaporator coil, and then we'll power it back on and see if we can reach temp the proper way. Alright guys, we've been running for about 10 minutes. And you'll notice our bubbles are starting to slow down. However, there's still a good amount of bubbling in there. But keep in mind with R404, it is a non-azeotropic refrigerant, just a fancy word meaning it's a blend. So at different ambient conditions, the various blends in that refrigerant will boil off. Now, I don't think that's what's going on here. We most likely are just a little bit low on refrigerant, or still dealing with a little bit higher load than I'm used to inside the little box here. So we're at about 20 degrees, nothing too crazy. But just keep that in mind. Before you just throw your gauges on, once you see a sight glass flashing, make sure you have proper airflow through your evaporator and your condenser. And then also keep in mind, for example, if it's, I don't know, maybe the fall, it's 60 degrees out, you have a high load on the box, that R404 is a non-azeotropic refrigerant, a blend, and it does have a glide, so it can bubble like this and not be low on charge whatsoever. Normally that's under special conditions, but now is not the time to really get too in depth with that. But I notice our bubbling is starting to slow down. I'm going to give it another few more minutes. If we get down to 5 or 10 degrees and we still have bubbling in there, I think I'm going to attach my gauges. Now, we do have a receiver on this system, I'm not really too afraid of overcharging it by dropping in a couple ounces to clear my sight glass. So let's give it another few minutes and then we'll revisit this issue. So before I go any further and attach my gauges, check my charge and all that, I'm going to get this coil all cleaned up. I'm going to do it in place because trying to remove this condensing section is very difficult. You have to take these side panels off, take this side panel off, take this whole front cover off. Then you can pull the condensing sled out to clean it. So I have a floor drain nearby. We're just going to clean it in place. We'll let the floor drain take the brunt of everything. Using this new, somewhat new coil cleaner today. Not too bad. Kind of like it so far. Alright, as you can see, our condensing coil is nice and clean now. Just cleaned it myself. We just turned it on, so as our evaporator fans start to circulate air over that return sensor, our temperature will kind of fluctuate. But what my main focus is on this sight glass, to see if we still have bubbles in this sight glass, and to see if I need to attach gauges and further diagnose or not. Alright guys, so it looks like we don't have any bubbles in our sight glass anymore. So let's just watch it get down to temperature. And right now there's no justification for me to put my gauges on this system. Now it does have a receiver, but it is also critically charged, and I don't want to remove any of the refrigerant unless I absolutely have to. So right now, I don't feel the need to attach my gauges, so we are not going to. Alright guys, let's do a quick recap here. We're at 3.7 degrees. This did reach temperature and shut off. I powered it back on just to verify that we do have this little orange fan symbol. That is what comes on when this controller is supposed to be sending power to this fan terminal right there. However, that's not happening. I verified with the manufacturer that it is okay for me to jumper this fan and compressor. Just put them on the same terminal like I did. It doesn't void the warranty at all. So we're safe there. The one thing I do want to mention, if you do run into this situation, make sure you know which wire is which. I know this top wire is to my evaporator fans. I'm going to mark it with a little paint marker. You definitely don't want to hook them up backwards, because those evaporator fans do cycle on and off with a with a evaporator sensor. So you'll have probably some sort of wonky issue if you get those switched around. But other than that, guys, we are all set. We should reach temperature very shortly. All right. Hope you enjoy. Like and subscribe. Shoot me some comments if you want.
Hey guys, so today we are going to change out a compressor on a train unit. And I'm riding in a 45-foot articulating man lift because it's a 90-pound compressor and I don't want to throw my back out. So, got all my stuff loaded up here and we are slowly making our way to the roof here. If I can figure out how to use this articulating man lift. Hang on. It's going to be a bumpy ride. So, as you know, I was originally here to change out a compressor on a train unit, as we discussed on my ride up here in my articulating man lift. However, when I got eyes on the unit, I realized that there's a lot more wrong with the system than just a simple compressor burnout. Now, this compressor burnout, all three terminals blew right out of the compressor, blew the charge, burned oil everywhere. But that wasn't the biggest issue. There's a couple other key issues here that should have been caught in our quote, and they were not. And it's most likely just due to a lack of experience. So I'm going to show you guys some of the things that I caught that we need to address now, and we need to requote. Obviously, it's not
not a simple job like I originally thought. So, and again, this isn't knocking anybody. This isn't knocking people new to the trade. It's just, hey, you don't know what you don't know. Simple as that. So I'm going to show you guys the things that I noticed and kind of explain why we need to requote and why these things are so detrimental to a system like this. All right, let me flip this camera around. All right, guys, here's what we're looking at. Now, this is the compressor that I was going to change out right here. This unit originally had a Rotolock compressor. It was retrofitted with this scroll compressor, which, no big deal, right? That was about a year ago. There was a date on that filter dryer that said last year, July 25th or something like that. And real quick, right over there is our fantastic burnout. All three terminals blew right out. Used to be attached to this. See if we focus there. Yeah, so it's a pretty good burnout. Now, obviously, we quote, in a situation like this, we quote for a new compressor, the burned out compressor plug. In this particular instance, I would have also quoted for some RX11 flush, some acid scavenger, or something to deal with a possible acid situation, since there's really nothing left. There's no gas in there. I can't, without actually taking the compressor out, tipping it over and seeing if there's any oil inside, there's no real way to test for acid in the system. However, usually with a burnout like this, it's attributed to acid being in the system. But what I got to noticing right over here, and this is just a theoretical idea, but there's a little tiny pinhole leak right there that you can barely see. So I got to thinking maybe all of our refrigerant leaked out from that little tiny pinhole leak and our low side pressure switch had failed. So I took the wires off and I tested it. It is open now. I don't know if maybe it's stuck. I don't know. So I don't really trust that low side pressure switch anymore. So, and I always replace them in pairs just because. So I'm gonna requote. I'm gonna get a low side pressure switch, high side pressure switch. But the best part, if you hadn't noticed already, if we follow our hot gas discharge line right over yonder, you'll see that when this system was retrofitted with a scroll compressor, they put the filter dryer on our hot gas discharge line going into our condenser. Now, what I'm afraid of is the desiccant beads inside there have come loose and have made their way into our condensing coil. I'm not sure if that's the case yet. What I'm going to do is I'm going to cut that filter dryer out, take a look inside there, maybe blow some nitrogen through it just to see if any beads come out. And then once I do that, we'll have to readdress the situation. So let me cut that dryer out, see what's inside, and then I'll show you guys what I find. Alright guys, so I got my filter dryer cut out. Not the one back there. That's just an old one that was abandoned when this previous hack retrofitted the system. So the filter dryer, it doesn't look like the desiccant came out of it, but it is severely plugged up. I'm actually going to take my angle grinder and just kind of cut it open real quick and show you guys what's on the inside. But it's logged with oil, and if you probably not showing up on camera very well, but I mean, there's just lots of oil just trapped right here in my condenser. So looks like we didn't have proper oil return is what I'm guessing, and that's what burned out our compressor, and possibly acid too. There's a lot of possibilities in this one. So we have a burned out compressor, a pinhole leak, a horrible piping job, filter dryer installed in the wrong spot, and oil logged in our condensing coil. So yeah, we're gonna have to make a full day out of this one, guys. So when I come back, I'll probably film it, kind of show you the process of repiping all this. It'll be a fun one. So let me go grab my angle grinder and cut this dryer open and see what we can see. Alright guys, here's our filter dryer. sliced it open real quick. It's not as clean of a cut as I'd like, but I'm not at home in my lab, so it'll have to do. Now keep in mind, some of this crap inside here is probably from cutting it open, but if you look at it, most of this stuff is, let's see if I can get this out of there. See our screen right here. Well, this is the first time I've ever cut one of these open. But this screen right here is pretty saturated with just oil, what appears to be metal slug, maybe burned oil, I'm not real sure. Now underneath, let's see. Now where I pulled the filter dryer out, underneath of it, it's actually got metal flakes. And I don't believe cutting it open would have got metal flakes underneath this I forget what it's called, filter dryer core of course, but little desiccant beads. I also thought that these desiccant beads were loose inside the filter dryer, and maybe they are in other filter dryers, maybe just not this one. But this one just seems like a solid core of desiccant material or desiccant beads. But it's definitely saturated, very, very saturated with oil and all sorts of other fun stuff. There we go. Break it up a little bit. Why not? Why not make a mess? Hey, that's pretty cool right there. On the job training, that's what this is, guys.
But just a quick recap. I know we didn't really diagnose anything, but the point of this video is just to kind of reiterate the point of always look at the big picture, look for other stuff, especially when you're quoting something like that. Had I just blindly come in, swapped that compressor out, I wouldn't have done my customer any real service. It may have ran for a while, probably not, because the compressor was just, or the filter dryer was just plugged full of oil and gunk. But you have to kind of look at everything. Look at the big picture. You know, like Chris Stevens always says, big picture diagnosis. And he's exactly right, though. You have to step back and just take a look at the big picture. So, and that is the point of this. For all you new guys out there, take a look around. Don't just see a burned out compressor and say, yep, we need a new compressor, new contactor. You know, kind of look around. What caused that compressor to fail? What murdered that compressor, as Brian Orr would say from HVAC school? So, yeah, that's the point, guys. That's all I got for you. All right, like and subscribe. As always, leave me some comments. Shoot me an email. If you see something I didn't see, got any points, opinions, ideas, whatever you got, let me know. All right, we'll see you on the next one.
Hey guys, so I got a different one for you today. Something I've never seen in my 12 years of doing this, and I figured I'd share. Now, I didn't get any of the diagnostic process on film, but I'll give you a quick recap. I got sent out to a retirement home where the kitchen was really warm. AC in the back wasn't working properly, they said. I got here, looked around, found a very large carrier package unit sitting on the ground with external ductwork. It's from 2017. Looks just about brand new. I don't know exactly when it was installed, but my stage 1 compressor was froze up. Stage 2 was starting to freeze up. My evaporators mostly froze up. Yeah, I did my usual, took my temperature splits. My supply side temperature was 60. Return was about 78. And it never really changed, which was odd. But blower was going the right direction, had proper airflow, filters were nice and clean, yada, yada, yada. I didn't attach gauges, of course, because again, my evaporators froze up, and without proper airflow, there's no need to adjust attach your gauges. So let me open this top panel up and show you guys what I found here. It's a little nuts to me. Hope you enjoy it. All right, guys, here's our unit. Now, the ductwork is slightly confusing. It's kind of crisscrossed. I'm not exactly sure why. I don't have access into the attic of this location, so I don't know I don't know exactly where that ductwork even really goes. But as you can tell, further away is my return, and this 90 corner that we see right here, that is part of the return. Obviously down there, that's our supply, right? So initially, it's thawed out right now, but this compressor was froze solid. My evaporator was froze solid. So come over here and there we go. Now, I'm not sure how long you guys have been in the industry, but your ductwork, which again, I'll show you right here, probably already know what I'm leading into, but if you look right down there, there is no hole for the ductwork. Now, there is a panel that you can remove, but they have the ductwork fastened to this panel right here. This panel right here, you just take it right out, and you just attach your ductwork from there. But this panel is screwed in place from the factory, so I can't pull that panel out. I can't pull that panel with the ductwork in place, so the only other option is to remove the economizer, and then we can get in there and probably cut a hole in that panel to actually get a return vent. So that's what I'm gonna end up doing. Let me get you a little bit better angle from around the other side here, guys. See, right there. Hopefully that's coming through crystal clear on camera. And even down there, when you look down in our economizer, I mean, it's not like they even tried to cut half a hole. There's literally no hole for that vent. So we're gonna have to pull that entire economizer out and then just come back with an angle grinder and just cut a big old hole right there, seal it up, and get them some return air. So, all right, guys. So I decided to check this other unit, right? There's the unit we were just looking at with the return that has no opening. And I decided to come over here and get some eyes on this unit just to show you. We basically have the same setup here. Return duct, externally vented, blah, blah, blah. That we got on the inside here. And again, there is no return opening. Filters are nice and clean though. I don't have to replace those. That's cool. But yeah. So we're gonna have to do the same thing on this one. Remove that entire economizer, and or maybe we'll just pop that duct off and remove that panel. But I don't know. I'll have to think about it. See which is easier. Just pulling that economizer out and then cutting a hole, or taking apart that ductwork and trying to put it back together might be kind of a pain. So yeah, we'll figure that out later. But once we do that and return proper airflow, then we'll have to see if these compressors still work, and see if if they still want to pump after 2 or 3 years of pumping liquid for the most part. The manager thinks these were installed about 2 or 3 years ago. She's not exactly sure of the date, but she did say that they never seemed to work properly, and right there is the reason why. So, all right, guys. Yeah, moral of the story here, they do not make ductless package units, okay? So don't let anybody tell you they do. If somebody says a package unit doesn't need ducts hooked up to it because it's ductless, they're lying. All right? Hope you enjoy this, guys. Like and subscribe, and we'll see you on the next adventure, all right? Hey guys, just a quick one here today. So I have a unit with a squeaky belt, and I have some new belts for it. And what we're going to do is we're going to remove this old belt, clean up all the pulleys, wipe down all this belt dust, and put a new belt on there, make sure our pulleys are lined up, and get rid of this squeaking noise. I thought maybe this would be a good little clip for some of the newer guys out there. Alright guys, so we're going to start by first removing our old belt here. Cracked in a few places. This particular unit has a spring tension arm. We just pop that up out of the way, pull our old belt off, and there we go. Now, only because there's a lot of belt dust, I'm wearing gloves today. And what I'm going to do is I'm going to use some of my Great wiper cloths, and we're just going to get a majority of this dust off all of these pulleys. I was always told that this dust is what causes the squeaking noises. So there's no point in putting a new belt down there if we don't get all the dust off of it. Try to get it off of everything, just so we don't put a new belt on there and then maybe some of this dust just reattaches itself to the new belt. So, plus it looks better. Even if you guys are the only ones to see this, it'll still look better. Clean up my pulleys. And just give it a quick spin. Look at all that crap we're getting out of there. There we go. Now, as I'm cleaning these also, I'm just kind of checking these inner edges, make sure they're not flattened out or warped in any other way at all. And these look really good. They're just really, really dirty. I know you guys are probably thinking this is a little bit excessive and it's not really a real world situation. But in my mind, right now, in order to guarantee that there won't be any more squeaking from this belt, anyway, I'm going to get rid of all potential problems. And one of those potential problems is excessive belt dust being on everything else. So, a little dirty. All right, nice and clean. Get a little bit of dust off my motor housing. That'll help it stay cool in the hot summer months. Dissipate some of that heat from running all the time. Now these particular wipes I like because they don't leave behind any sort of residue. When they dry, the surface is nice and dry. It's not oily, it's not slick, there's nothing left on there. Alright guys, so here's our new belt. That on. Lift up our spring tensioner. Now, right here, this is really what I'm focusing on this one. You can see in there, it's worn a little bit more than the rest of them, but it's not terrible. I'm also looking to see how this V shape right here on this belt rides on this inner V shape of this pulley, and it looks pretty even. I'm not really concerned about that. It's borderline. I could almost close it down maybe a half a turn, but at this point I don't really see a need for that. It looks pretty darn good. So it's nice and clean. Nice and clean. And that's it, guys. That's just a simple belt change and pulley cleaning. All right. Hope you learned something. Like and subscribe, guys. We'll see you on the next one. All right. Today we're looking at a carrier package unit that is not cooling properly. Anyway, this particular unit is handled by an energy management company. I have verified with them that there is a call for cooling, so as soon as I turn it on, it should cool. Let me pull off some of these panels, and then we'll dig into it, and I'll bring you along for the ride. All right. I was informed that there was another company out here working on this unit, so before I start it up and really do anything else, I decided to pull the panels off and just give it a visual once over, see if I can see anything obvious. Looks like we've had a little bit of smoke detector work. There was a alarm company here when I got here, so maybe, doesn't look like they replaced the smoke detector, but maybe they did something with the smoke alarm system. I'm gonna put a zip tie on that. That's kind of flopping around like that. Obviously that panel was on there. I just took it off just so I can kind of look at everything first before I power it on and get started. It was on when I got here. There were no fault codes or anything like that. This particular unit is capable of showing fault codes for the heat circuit, but nothing for the cool circuit. But yeah, belt looks good. There's a spare right there. Blower is nice and clean. Evaporator is nice and clean. I mean, no burnouts. You can tell where some wiring for the old smoke detector used to be. What they would do on most of these, they would just break our control voltage. Although they probably shouldn't leave these wires just bare like that, flopping around. All it takes is for one of these wires to touch something and short out, so I'll address that a little bit later. But I don't see anything alarming on this, so I'm gonna pop these panels back on and we'll start it up and see what she's doing. All right, I just powered the unit on. I got my meter and a common side. Just want to make sure we have 24 volts on our red on our terminal board. We should have a Y1 signal, 25 volts, which we do. We don't have a Y2 yet. This particular location doesn't go into Y2 until the inside ambient temperature reaches 76. So we're still in stage 1 cooling, but I don't have any compressor action yet. And we do have an economizer, so chances are it's maybe thinking about doing some free cooling. And no, it doesn't look like it's open, so it's probably going to go through the economizer, run for a little bit, decide if the mixed air temperature is going to be enough to cool the space down, and then it'll kick over to stage 1 in probably just a minute or two here. We've been running for about 5, maybe 10 minutes by now. I still don't have any compressor action. I did just verify. I still have a Y1 signal, but I have nothing to any of my contactors. You see right there, nothing. Oh, that's my indoor blower contactor, sorry. So we'll step up here and we're going to check our safety circuit, logic circuit, pressure circuit, whatever you want to call it. The right side is our incoming power going into the board from our economizer. I have nothing. Here's our stage 2, nothing. Again, nothing. I have no voltage going into my logic circuit. So now, since I don't have anything coming into my logic circuit, my safety circuit from my economizer, let's go down here and check this out. So we have Y1 right here. That's our verified 24 volts that we already double checked. Comes down, goes down into, comes out of the board actually after it comes in from our thermostat into our low voltage terminal board. Comes down and it goes out of this Molex connector over to our economizer. Then blue, this is just an optional jumper that's right here. That is not installed on this unit. So we follow our blue all the way over here, and then blue will go up in here to terminal number 1. Now, assuming, since this is Michigan, I like to set my economizers on D, which is only free cooling, I think at 63 degrees. So, assuming this is set up properly, we're not in free cooling, this relay should close, and I should get 24 volts back through this gray wire. This number 5, I believe, is just a dummy terminal, but we should get 24 volts coming back through this gray wire, coming down, down, down through our gray. Forget about this jumper, come back over here, come back over here, and this is our returning gray. So once we return back to the control board, the low voltage terminal board, we come in through here and we go over here to an optional reheat control. Now there's nothing right here, but if you look at this little jumper, which if you do have the reheat control in there, you cut that. So we come over here on our number 5, our gray wire, and this actually jumps over here. So let's follow this jumper back around here, and we go up here, up here, up here, over to 4 on our compressor 1 circuit. Then we follow this little violet jumper to our number 5. From number 5 we go into low pressure in, go through our low pressure, out the low pressure, and then over to, this is also an option, we don't have that. So we come out of the low pressure, come in to the high pressure side, and then we go out this, and assuming these pressure switches are closed, which they should be, we come back over here to 6, and then 6 is our blue wire that goes up through an optional low ambient kit, which we don't have on this unit either. And then from there we come into our contactor. So I am guessing that somewhere in this economizer we have an issue. So let's go check out the economizer real quick. Not sure if that's picking that up on camera. Let me see if I can get a better angle of that. You can barely see it, but the free cooling light is on. It looks like our temperature set point is set at A, I believe. Yeah, it looks like it's set at A, which is 73 degrees. Even though it's hotter than 73 today, we still shouldn't be in free cooling. So I'm going to turn it over to D. So we should only cool at 63 degrees. Make sure my minimum position is set. All right. Let's see, here is this orange wire is our stage 2 going out. So right here, this is our stage 2 Y2 call for cooling if we were to have a stage 2. Blue right here is our stage 1. Now, if you notice this wire nut here, that's not supposed to be there. And if you look at this right here, so here's our stage 1 call for cooling. And it's supposed to come out of this terminal right here, but you can tell if it's picking it up on camera. I know it's kind of dark in there, but there's not a terminal on there. For whatever reason, somebody cut this and put a wire nut, but they left this side on our dummy terminal. I'm not sure why they would do that. Yeah, so let's just move that. Alright, so move this up to our number 2 terminal so that we should have an outgoing signal back to our control board. However, if you can tell down there, let me get these wires out of the way. You can see we're still in free cool mode. And it's probably 80, 82 degrees out here roughly. So, now this is equipped with a, you know what, look at that, see right here. Let's go back over here and check our schematic real quick. I want to double check something before I start spouting off at the mouth. Let's see, I just noticed something over there, yeah, right here. So real quick, let's track out our stage 2, just because I want to show you something here in a second. So if we had a call for stage 2, it comes down here, goes down through here, through our number 4. This is just a little reminder that it comes back up through our orange. But we come down through yellow, number 4, come over here, yellow, right here. So this is our yellow. And right here, we have a low ambient lockout, and it's just a bimetal thermostat that's just sitting on the cabinet over there. And then once we get over to number 3, assuming this isn't calling for free cooling, which it still is, we would have a signal coming out from orange, and it would come back here, and it would come out through this orange. Now, again, just like stage 1, when we come back from our orange call, it'll come over here, go over here to our optional reheat connector. It'll come down to this jumper, which you can cut, and then this jumper connects over to here. We go up to our number 4 on our compressor 2 terminal. We go across this violet jumper right here, follow this dotted line down here. That will take us to our low pressure, high pressure circuit. We go in our low pressure side, go through the switch, and we come out the other side. Then we go back into our high pressure side, go out the switch, come out of the high pressure side into this dotted line into number 6, which turns into our orange wire, goes to this optional low ambient kit, which we don't have, and then we go into our number 2 contactor. Now going back over here, I seen this low ambient lockout kit, but the wires going to it are not yellow. So let's go, remember that, let's go back over here and double check this. I think somebody got into this economizer and started messing around when they shouldn't have. So if you look right here, this yellow wire right here is our incoming Y2 signal. Now keep in mind we don't have a Y2 signal, so I'm not too concerned about that because there's a jumper on it, which is fine. I'm okay with that. It's an optional jumper, you don't have to use that. But if you look over here, this orange and green wire are on this low ambient lockout switch. Now we follow this over to our economizer board. That orange and green go to SO negative, SO plus. I forget what that means, supply outdoor or something. We'll come back over here. Let's follow this. So SO plus, there are different colored wires, but SO plus and SO negative go to an outdoor enthalpy sensor. Which is not what they're hooked up to. So let's go back over here. I already removed this filter. Now if you look right over here, there is an outdoor enthalpy sensor, and there's no wires attached to it. somebody put our wires that are supposed to go to the outdoor enthalpy sensor on our low ambient lockout. So let's move those real quick. Now, I'm not a genius when it comes to economizers, but I've seen this a couple times where people either think they know what's going on with economizers, or maybe they think they know a trick to get them going, or they just don't flat out understand them and they just start putting wires on stuff. So it's not that uncommon to see. All right. Put that in there. All right. Now we are connected to our outdoor enthalpy sensor. Let's power this back on. And if my calculations are correct, we should no longer have free cooling. Immediately my compressor came on. We get in there. I don't know if it'll pick it up, but our free cooling light is no longer on. Let's go back over here. We can see our stage 1 compressor contactor is pulled in. 24 volts going to it. All right. Now what I'm going to do is I'm going to initiate, I'm just going to jumper a call for stage 2 cooling just to verify that our stage 2 comes on. And it came on immediately. And then we'll just verify at our high pressure switches just to show you what I was talking about earlier. There's our 24 volts going in, 24 volts going out. Our contactor is pulled in. Let's get a quick amp draw of our compressor. I still have to go back and close the air damper over there. Well, I can't get on there to get an amp draw without cutting some zip ties. I'll have to cut some zip ties here in a minute, guys. Alright, let me put these panels back on and get a proper amp draw, and then we'll start taking some supply temps, alright? We've been cooling for about 10 minutes now. I have a supply of 54.1 at the unit. Return of 77. So we got 23-degree split right there. That's pretty good. Our trap is still really dry. It's been dry for days. So all that's left to do now, guys, is call our energy management company and make sure they have proper communication, and we will be all set. It looks like whoever was here before just miswired our economizer for whatever reason. The initial call that sparked that, I'm not sure. I don't really have time to speculate why they were sent out here or whatnot. So anyway, that was a pretty interesting one for me, guys. Hope you enjoyed it and hope you learned something. We'll see you on the next one, all right? Like and subscribe. Shoot me some comments, some emails, tips, anything you got, all right? Today, we are in my shop, my lab, my garage, whatever you want to call it. And sitting right back over here, right there, we have a semi-hermetic compressor, a K-body compressor. Now, I never get to work on these. I never service them. Unfortunately, I'd like to. I'd like to do that a lot more. But I happened to come across this K-body compressor while I was on another job. I noticed that they had a couple condensing units that were just abandoned on this roof. Talked to the manager, asked if I could steal one of these compressors for this very purpose because I want to tear it apart and see what's inside. And they said yeah, so I took it, cleaned it up, and here we are. Now behind me on that whiteboard, you'll see a little bit of information on the compressor. It's a R404, uses POE oil, run load amps, about 4 4.6, I think it was, 3,000 BTU at negative 25 degree evaporator temperature, 105 degree condensing temperature. And then the book over there you see, that is Modern Refrigeration Technology. I was just kind of poking through that a little bit about in the semi-hermetic compressor section. So yeah, let's dig into this. Austin from Lima, Ohio, if you're watching, you're gonna like this one. We're gonna tear this thing apart and see what it's made of, all right? Stay tuned. Before we get started, let's just take a quick look around at this thing here. There is our model and serial number information. I cleaned it all up. It was pretty dirty when I got it, but it looks in pretty good shape. It was sealed up, so there was no moisture present. It wasn't just sitting out in the elements, so I think the inside will be pretty pristine. It'll be a good teardown. And there's just a quick view of the book we're looking at. Just basic components: cylinder, piston, crankshaft. Again, guys, I'm not an expert on these, but I tell you what, I'm going to tear it apart anyway and see if I can't learn something from it, all right? Because I'm just a curious guy at heart. So let's get to work. All right, so first thing, we are going to pull this wire off. This looks like it was to our, I'm going to say, our high pressure switch. Yeah, it must be our high pressure switch. It's rated at 375 PSI, so this is just broken off. I'm just going to disconnect that. I'm going to start by just taking apart some of this electrical stuff. Looks like we got an original wiring diagram in there. Let me get some of this stuff cleared out of here, guys, and I'll show you what I'm looking at. Just a bunch of cut wires from probably when it was abandoned. Looks like they just kind of cut stuff right off of this thing. So, all right, guys, let me show you what I'm looking at here in this electrical section. There's our wiring diagram. Right here you'll have our line 1, 2, and 3. This is our thermal overload protector. And these right here are the terminals going into our windings of the compressor. We still got the original paperwork, it looks like, too. That's pretty cool. So I don't really need to do anything with this section, although I might. Actually, it looks like it does come apart, so I think we might just tear that apart as well. All right, let me set you down here. I don't really know if I want to tear that entire electrical section apart yet. Let's start with the big stuff. Let's start with the fun stuff. First thing I want to do is get this old broken switch out of the way. This pressure switch. Get that off there. I don't really have a reason to pull off these valves. Suction line on this side, discharge on this side. See, now I might be wrong on this, but I was always told if the suction line on a semi-hermetic compressor, if the suction line is closer to the actual motor of the compressor, which I believe would be right over here, then it is a suction-cooled compressor. Since this one is not closer, I believe it's an air-cooled compressor. All right, real quick, I just kind of removed part of this electrical housing just to get a better view of it. Now it looks like I can just take these to get this electrical block out of the way. Let's do that. Let's get those right out of there. I lied, I am going to take this electrical portion apart to see what's underneath of it. And then we'll get to the big stuff. It's the reason we tear things apart, right? Just to see what's inside. Where's the fun if you don't tear everything apart, right? All right. There's our thermal protector right there. Set that over here. I really need that. Let's pull these off here, see what's underneath here. Interesting. Well, that's pretty cool. Look at that. You can just pull this right out of there. So it looks like this is like a serviceable part anyway. You could take this off and replace it. Of course, you'd have to pump it down, obviously, but that's pretty cool. Interesting. Well, I didn't know you could do that with semi-hermetic compressors, so let's keep going. We'll start at the back side here, I think. I think I will pull these valves off just for the heck of it. Nothing too crazy, just a normal looking return, or excuse me, high side discharge valve. Doesn't look to be damaged. I don't see any oil buildup in there, any carbonized oil. Gasket looks pretty good. Yeah, nothing too crazy on this. So I'm just going to put it back on there. If I don't, I'll probably end up putting it on the wrong side. And our suction side, nice and clean. Gasket looks good. Inside of the valve body looks good. No carbonized oil in there. And again, guys, I don't know if this system had any issues. It looks like it was just abandoned because they installed some new equipment. There was a new condensing unit sitting next to this one, so it probably ran fine up until the day they shut it off. Alright, the next thing I'm going to do is I'm going to pull apart the back side of this. Spin this around and give you a little bit better view here, guys. Alright, we're going to pull this apart because I have no idea what's behind there. oil. A little bit of oil. This little thing right here, no idea what that is. I didn't see that in any of my books. It's odd because it, I don't know, this bearing, or part of this bearing, whatever this is, only spins around one way and then it hits a stop of some sort. So, I have no idea what that is, but let's put that back and then we'll tear the rest of it apart. This electrical stuff out of the way. Put that right there. Now, I didn't drain the oil out of this just because there might be a bunch of oil that comes spewing out of this at some point in time. Let's see. Let's see if it's full of oil here. That's not really letting me pull this all the way out. So we're probably still attached to our pistons. All right, let's pull this top off. Take all these bolts out. These two center bolts, I kind of thought they may hold the reed in there or something. So let's see if that does it. There we go. Interesting. There's the head of our compressor right there. Again, looks pretty clean. These reeds right here. It looks like they do come off. I don't believe that's part of the problem. It looks like they sit right on top of this valve body like so. This is a dirty job. Need to get Mike Rowe over here. Yeah, so it looks like they sit just like so. Take this one off. I'm only putting them back over here so I don't lose any parts. See, that's our little reed right there. And so basically when the piston moves up and down, this will just flex up and down with the piston as it's basically sucking and pushing the refrigerant gas through the compressor, of course, as it's sucking and pushing refrigerant gas. Trying to see if there's a way to get this valve plate off of the head. It looks like there is, but it's probably, no, not stuck on there very well. Nice. And these are kind of cool. You can take everything apart on these. So, right here, this part fall out. I don't really know what that goes to, but that's all right. And so this is the back part of our backing plate. As far as I remember, these are, I don't remember the technical term for them, but it's a backing plate that'll keep the reed from opening up too far, from springing open too far. I'm sure there's some sort of engineering technical name for them, but I guess I refer to them as a backing plate. But and again, it looks pretty clean. I mean, this is a nice and clean looking system here. All right, let's put that back like so. Give you a little bit better view here, guys. This is what we're looking at. This is the top of our compressor. And see right here, these are our reed valves. Real simple, these pistons. Once I get this part of the compressor open, I'll see if I can't just spin these pistons around and give you a better view of how they work. But as these pistons go up and down, these reeds will go up and down, of course, and they will open and suck and push gas through this this valve plate, this valve head. You look right down in here, it looks like we have a strainer of some sort. I don't know if it's going to pick it up on camera. All right. Let me spin this other side around, and we're going to take apart the back side of this. Put one of these bolts back in so it doesn't just fall apart on me. Oop, my bad. Alright, let's take this thing apart. Nope, wrong side. That's metric. That's different. Alright, let's pop it open. See what's back here on door number 3. Alright guys, there's our motor. Looks sort of like a wind turbine. I wonder, that'd be super cool if I did. I don't have a socket big enough for that. Alright guys, let me show you what I was talking about a few minutes ago. They come right over here to our pistons. As I turn the motor, you can see how they're pumping up and down. And of course, as one goes down, it sucks. As the other one goes up, it pushes, and the reeds will move accordingly. Yeah, the part that's confusing so far is, I guess, where's all the oil? I kind of expected this thing to be full of oil, but it's not. And I don't honestly remember if the condensing unit had an oil separator or an oil reservoir. If it did, I guess that's where all the oil would be. But, yeah, it's kind of bizarre. And I don't have a big enough socket to get this shaft apart. I believe if I take this apart, I can separate the crankshaft from the motor, but I'm not 100% sure, and I don't have a socket big enough to take that off. So our demonstration may end right here. All right, well, let me put that back on. Can't do much more on that side. Actually, I'll leave that off. Before I wrap up, I'll give you guys a little bit better view all around this machine here. All right, here's a little bit better view. See, right here, that's our motor. This is our rotor, our stator. There's a little bit of oil in the bottom of that. Not as much as I expected, though. Here's our electrical section. This is where our line 1, 2, and 3 would hook up to again. These are the terminals going into our compressor. And if we look right, I believe it's right up there, you'll see right up in this corner, I might not be picking it up on camera, but right up in this corner, you'll see the wiring that goes up to our terminals. And then right here, this is it would be the top side of our valve head. So how this would sit on our compressor, this would sit, I believe, this way. Oops. Let me get this right here, guys. Yes, so it would sit this way, like so. See if we can see anything happening. Now you can hear the pistons. You can kind of see the reed on the left-hand side there. You can kind of see it bouncing around a little bit. So now imagine that like a million times faster. And again, for those of you who haven't seen one of these in action, that's basically what you're looking at. Yeah, pretty simple stuff. Not too crazy. It operates exactly like a hermetic compressor. It's just bigger, and as far as I've read, the valves, the gaskets, everything, it's serviceable. Actually, the inside, you can replace the valves, I think. Gaskets, of course, you can replace those. You can replace these valves, pistons. That's what I meant by valves. You can replace the pistons. You can replace these valves as well. I would imagine, I don't exactly know how to get this apart yet, but I would imagine you can service this crankshaft and the bearing that goes with it. But I believe we have to get this giant bolt out of there, and I don't have a socket big enough for that right now. But I believe you take that off, and then you can pull this cover off, and that'll show you the bearing that's inside that holds the crankshaft in place. All right, guys, that does it for today. Hope you enjoyed the video. If any of you guys out there are more familiar with these, shoot me some comments. Let me know. Give me some names of some components. See something I missed, something I named wrong. Feel free. Let me know. I might learn something from you, and that would be awesome. But Hope you enjoy, guys. Like and subscribe, and we'll see you on the next one, all right? All right, guys, we're back on site at our carrier package unit, 25-ton package unit. If you watched my last video on this unit, it is titled My Carrier Can't Breathe. This is the one where our return ductwork was never actually cut into our unit. So this ductwork right here just goes into a flat panel, which you'll see once we remove this economizer. So our plan today is to remove our economizer, cut a hole for the return air, and then return proper airflow. We're going to check our heat exchanger in this as well, because it's probably been overfiring and going off on thermal for the last 2 years. And then we're also going to basically recommission everything. We're going to hook up our gauges, check superheat, subcooling, temperature splits, make sure our compressors are fine. Basically go through this with a fine-tooth comb, because for the last 2 years it's been struggling to survive. So that's our plan, guys. Let me get this economizer removed, and we'll show you what we plan on doing. Now that we have our economizer exposed right here, what we found way back in this corner is this little cutout right here. This triangle is actually cut out. Now on my initial visit I missed that because I was looking through the top and through the control panel down through my return air, and looking at it from that angle it looked like it was closed off. Now this up here, this entire section is closed off, so I was kind of scratching my head as to why they would just cut out this little tiny triangle piece. This is a 25-ton unit, and I don't do airflow, balance testing, anything like that, but a little triangle cut out of that doesn't seem like it's going to provide enough airflow. So I believe what they did was they put everything together, put the ductwork on there, realized their mistake, and then came back and cut this open. They just cut this down here because it was the most accessible part of it. I don't believe it has anything to do with proper airflow balancing. So what we did is we went over to the twin to this unit, which has the same exact problem, and we took a static test, and I was bouncing between 0.35 and 0.4 inches between my return and supply. And what we eventually found, our stage 1 compressor wasn't coming on because our low pressure switch had failed. So we attached our gauges, bypassed that low pressure switch, got it running, and right now I have a supply temp of 52 with a return of about 74, so I do have about a 20-degree split. My high side pressure looks okay. My low side pressure though is a little bit lower than what I'd like. We're looking at about a 35-degree evaporator, which still indicates to me that we don't have enough airflow across that evaporator. And if you watch it, it bounces around between 32 and 35, which I'm going to chalk up to airflow at this point. Or possibly our TXV hunting. I just have to open up that evaporator panel and verify that I do have a TXV. I can't remember from last time I was here. But that's where we stand right now. So we still have an airflow issue that we need to correct, but we're slowly discovering a few other issues that we're working our way through. So we're going to take our time on this, guys, and look at the big picture, all right? Oh, and if you're wondering, I just have my analog gauges hooked up down here, and it was just kind of an afterthought. I just got this hanging here for the temperature clamp right here. We're going to replace this low pressure switch, so once we reclaim all the charge, braze in a new switch, then I'll get my digital gauges hooked up properly. All right, guys? So we got our economizer out right here, right down here. If you see this lip right here, I had to cut that while the economizer is in place just to get it to come out, because I wasn't able to move this corner post. See right there, we had to fight it a little bit, but you can kind of see it a little bit better. I climbed right inside here. That's the little bit of airflow that we did have. So we definitely had airflow problems. It just wasn't a complete 100% blockage like I thought it was. But like I said, our other unit over there, the twin to this one, It's down to about 32, 34 degree evaporator. Static pressure still seems to be okay, which is odd, but our evaporator is very, very cold. So we are going to slice that the rest of that panel off with my Sawzall right here. So let's get to work. Alright, as you can tell, we now have a proper opening. Now, we just got to put all that back in here. So let's get that started. As you can tell, we got our economizer reassembled. I do have the metal filters left out, so we're going to go ahead and clean those before I reinstall them. I feel like my magnetic umbrella kit, I just got that. So far it's not too bad. Don't have any complaints. The magnet's strong enough to hold it in place like that. It's not a real windy day, but my concern is when there is a windy day, how well it stays on a unit like that. Before I turn it on and recommission the system, check my airflow and everything, I'm gonna go ahead and clean this condensing coil. It's not real bad, but as I always say, you don't know if it's clean until you clean it yourself. Alright, so let's start over here. I'm going to spray it down and get as much gunk off there as I can before I do a chemical soak on it. Alright, let me get after it, guys. Here we are. And what I'm doing, really, I'm just trying to get as much dry stuff off as I can before I get my chemical on here. Get the coil nice and wet. It's going to help that chemical out a lot better. Instead of just spraying chemical onto a dry coil. Should probably get my test hose out of the way, huh? Yeah. This one's not too terrible, but if we're going to do it properly, we're going to clean it up. And as I've said before, I always like to try to spray straight down because you don't want to spray straight into the coil and push this gunk back into the coil. Just try to go straight down with it without so much pressure that you're going to bend the fins either. It's time to do a chemical soak. I don't know if I've touched on this before in other videos, but what I like to do is start at the bottom and kind of stack the chemical on top of itself. I seem to get better results that way. But hey, if you guys do it differently, put a comment below. I'm not sure where I picked this up at. I want to say that I heard it on HVAC school, or HVAC school. There was an episode with John Pastorelli, and I believe he was talking about how to properly clean condensing coils. Now this one, I got just a lower ratio. I think it's a 6-to-1 ratio because it's not very dirty. So we don't need full concentrate. Just enough to break up whatever gunk's on the inside and get it to fall down. Looks like I almost need to refill this stuff. Alright guys, let me grab a refill real quick. Alright, we just got our coils cleaned up, guys. One thing, I can't state this enough, if you're going to go through the trouble of cleaning coils, go through the trouble of washing away all the crap that you clean off the coils and anything around the coils. Once that water dries, obviously all that stuff's going to get sucked right back onto the coil. So, just get it out of there. If not, what's the purpose of cleaning the coils? Just a common sense tip right there, alright? Here's our blower compartment. I initially thought there was a way I could take this entire blower section and slide it out almost like a Lennox. However, that's not really the case here, so I still want to get eyes on my heat exchanger. So what I'm going to end up doing is just going in through my supply vent and seeing if I can't get my endoscope in there and getting some pictures of that heat exchanger, just to make sure it's not all burnt up and rusted out and everything. So let me go pop a hole in the supply vent and we'll try that out. Alright guys, so our coil's nice and dry. We're back up and running. We're in 2-stage cooling right now. Let's check out my return air temperature is 80. My supply is 55. We started off with a return air temperature of about 86, so it's coming down. My static pressure's kind of bounced around between 0.5 and 0.6. I'm not too concerned about that. I was able to get a little bit of a peek at my heat exchanger right there. Right where you see that 3M tape. I went inside there with my little endoscope and I just basically checked out the tubing on it. It looks pretty good. It's not all burnt up. So let's come over here, check out our pressures. About 116 on the low side, 324 on the high side. We got an evaporator of about 39. Condensing temperature about 100. I'm measuring 84 ambient in the shade, or 83. I take that back, 83. So I don't really have my 20-25 degree split like I like to see on these 410 units. It's a newer unit, so the newer units, my rule of thumb is usually 20-25 degree split. But it might be closer to 20 on this unit. Now I did let that condenser dry as best I could. We may have a lower condensing temperature because there might have been some water trapped inside. I don't have a leaf blower to go ahead and clean it or dry it off before I started it back up. But once we get all that water off there, our condensing temperature will probably climb up just a little bit.
In a minute here, I'm going to connect one of my gauges to my discharge side, and I'm going to use that chart right back there just to check our charge real quick. But right now, everything looks really good, so I have no concerns at this moment. If you guys can hear me, our discharge pressure is 343, 344. It's kind of been bouncing around 345 to 350. So if we come over here on our chart, you'll see I have it marked off at 350. Our refrigerant temperature leaving the condenser is 80, about 81. I have that marked off at 80. So if you just come over here, scroll down, we're borderline overcharged according to this. But at the same time, we are still under a heavy load because I'm still pulling back 82-degree return air. So since we're pulling back such hot return air and we're so close to right where it should be as far as that charging chart goes, I'm not going to do anything with the charge. I'm going to leave it the way it is. We're just going to let this thing run for a little while, get down to temperature, and then we're going to start on that unit over there doing the same thing. All right, let me get this mess cleaned up and transfer all this stuff over to the unit down there. All right, guys. We're down to 77 return. Got about a 53 supply. My static is about 0.5, 0.6. Let's check our airflow. Airflow is good. Let's see, is that about 200 CFMs? Yeah, look at that. It's about 200 CFMs right there. Alright, so I wanted to take a minute and just quickly recap that job we had today. I know footage was kind of all over the place. It was a little bit of a hectic job site today. I had maintenance guys and another technician with me, so it was a little bit of hit or miss, but I tried to get all the important stuff on film and narrate it as best I could for you guys. So as you could tell, when we first got that economizer out, we found that there was a little triangle portion that was cut out underneath that economizer. Now I couldn't really figure out why only that little section was cut out. I kind of gave the contractor who installed it the benefit of the doubt and assumed that he had balanced the air in a way that that return air was just enough, that they had enough outside air mixing with the little bit of return that they had coming through there. I know it's kind of far-fetched, but once I looked through the economizer and found that the economizer is basically set to its minimum position unless it's calling for free cooling, I decided that probably wasn't the case. So what I believe happened is that they got everything done and then they realized their mistake. After everything was put together, the ductwork was installed, they realized that they forgot to cut a opening for the return air, and then since that economizer is such a bear to get out of there, what they did is they came back and they just cut that little section out because it was easiest to do. So that's what I think happened. But yeah, so anyway, we pulled that out, cut it open, got proper return air as you've seen. Everything after that was just great. I would have liked to get a better view of the heat exchanger. I did have my little boroscope, endoscope, whatever you want to call it, inside the supply vent. I was able to see the tubing on the heat exchanger and it looked fine, but I kind of wanted to get a better view of it. But I just couldn't without cutting into the ductwork or removing the ductwork or gutting the middle part of the machine to remove the blower and everything. So that just wasn't really an option. But as you can tell, everything looks good on that. Pressures were good, superheat, subcooling, everything was good. We did just satisfy at 72 degrees about 15 minutes ago, so we're going to wrap up and get out of here. But anyway, I hope you like it, guys. That was the conclusion to my carrier can't breathe, and after today, this carrier can breathe now. So hope you enjoyed the video, guys. Hope you learned something. And also, thank you guys for watching. I really appreciate everybody who watches these videos. Thanks for the comments. If you have any comments, feel free. I'm all about learning stuff, so feel free to leave me some comments. If you see something I'm doing wrong, maybe something I missed, if you have a better way for me to do something, let me know. Let me know. I'm humble enough to admit that I'm still learning. I'm a student to the trades every day. All right, guys? So thanks for watching. Click like and also subscribe while you're at it. And we'll see you on the next one, all right? Here's our project for today, guys. We got a 6-ton train unit that was not cooling properly last night. One of my guys was here late last night, and they talked to me about it over the phone a little bit. The restaurant downstairs was at 81 degrees. The thermostat was set to 71 degrees. So over the phone, we had determined that the economizer was calling for free cooling, even though at the time it was about 90 degrees out. So we went through a little bit of troubleshooting over the phone, but there wasn't much we could do over the phone. It was getting late, so we ended up just unplugging the economizer and just letting it run in mechanical cooling for now. So what I'm going to do today is I'm going to plug the economizer back in, and we're going to see if it kicks right back into free cooling. Now right now, you can, if that'll pick it up on camera, we're at 93 degrees right now. So obviously there should be no need for free cooling. So we're going to go over here. Now this is our incoming power to our economizer. Let's plug back in. And my compressor just shut off. You can see our return is closing down. Our economizer is opening up. Let's get right over here. There should be a green light on there. That's, let's see. Yeah, see right down there in the bottom corner. That green light, when it's steady, the economizer believes it's okay to economize. So we're gonna let that go for a little bit and see what it's gonna do. My economizer hasn't opened up. My return started to go down, it started to close up, but then it went back up. So let's just see what happens here. Yeah, there goes our, now our return's closing down. Now it's going back up. Now it's going back down. Now it's stopped. It's going down. Seems to be going down in steps for some reason. Usually, from my experience, when these economizers close, they just go down in one fluid motion instead of an inch or two and then close down a little bit more. So that seems odd to me. We'll have to check out the hardware on that economizer damper just to make sure it's not getting hung up on anything. So my next step is to bust out the manual and go through and troubleshoot this economizer. Now I am not real sure where the enthalpy sensor is on this particular unit. It's probably underneath the hood over by those mesh screens, the metal filters that are in the economizer. So we'll check out the wiring on the enthalpy sensor. I'll get out the manual. We'll do some resistance checking to see if that enthalpy sensor is still good. All right, so let's get to work. All right, let me take you through a little bit of my thinking process here. So the first thing we do, this is one of the manuals I pulled out of the control panel of the unit. First thing we need to do right up here is we need to check our nameplate and see if the 9th digit is a R or an E. So we go over here and let's see, right there. So it's an R.
So of course that means we have the Reliatel control. So we need to find the section Reliatel control cooling with, not without, with an economizer, which is right over here. So I've already read through this. Essentially what it's saying is make sure your potentiometer is set to what you want it to be, which I have it set to E for 55-degree outside air. That's when it kicks into free cooling. The other thing I noticed here that's important is it basically has to run for about 5 minutes to allow the mixed air sensor to determine if the air that it's bringing in through the economizer mixed with the return air is going to be enough to satisfy the zone sensor. So part of me is wondering now if when we were on site last night, if we just didn't allow it to run long enough. For example, if I got up here and I shut the unit off, pulled some panels, and I turned the unit back on, according to what I'm understanding here, it should run in economizer mode for about 5 minutes until that mixed air sensor says we're not satisfying the zone sensor with the air that we're bringing in from the outside because it's too warm. That's what I understand from it. So what I was hoping to be able to do is, at the very least, ohm out my sensors. There's my return air humidity sensor and our mixed air sensor. There's an outside air humidity sensor. But in this chart for the Reliatel control, there is no temperature resistance chart. Now there is a temperature resistance chart if you have the electromechanical control. See, right over here is our electrical mechanical control section. Now we don't have that, so it apparently doesn't apply to us. So let's just ignore all that. So what I'm going to do now is I'm going to turn the unit back on and I'm going to let it run for about 5 minutes and see if maybe we just jump the gun at first. And then I'm probably going to have to call tech support and see if they can give me some documentation about how to check these sensors throughout this machine. Alright, let me power it back on. I'm going to turn my timer on and see what happens after 5 minutes. Alright guys? Well, my test did not go as well as I wanted it to. We're approaching the 8-minute mark since I've let the unit run. I was hoping that after the 5-minute mark that the manual said, the mixed air sensor would make the determination that it will not satisfy the zone temperature set point with the current air that is bringing it through the economizer. However, that has not happened, and we're going on 8-9 minutes now. So we still have a problem with our economizer. One of those sensors, I'm sure, is off. But as I showed you, there's nothing in the manual that really explains how to test those sensors on the Reliatel control. So I'm going to do some research online, see if I can download the manual, and then I'll probably reach out to tech support and see if there's an easy way to check those sensors. All right, I'll let you know what I find out. I just got off the phone with trained tech support. I was not able to find the answers I was looking for on any online forum. I was able to download a couple different manuals about this economizer and the unit itself and how to troubleshoot it, but there wasn't a whole lot of information on how to exactly test all of these sensors. So you'll notice that now I only have one sensor hooked up, and that is my mixed air temperature sensor. After my conversation with Train, what I found out, what I learned today, is that this setup, the way they had this set up with our outdoor humidity sensor, our mixed air humidity, or excuse me, our return air humidity sensor, and the other one, which is, I believe, return air temperature sensor. This unit was set up for something called comparative enthalpy. So it really doesn't care what the outside air temperature is, the dry bulb ambient air temperature. it will economize based solely on the relative humidity of the air. So today is a pretty dry day. I don't know what the exact humidity percentage is out here, but it's about 98 degrees in the shade. But it's a very dry day out, so the economizer is looking at the humidity of the outside air versus the humidity of the inside air, and it says, well, the outside air is drier than the inside air, so that's why it was going into full economizer mode. So basically, by unplugging the humidity sensors, what we did was we turned this from a comparative enthalpy economizer into a dry bulb economizer, or I guess what I would call a normal economizer. But I thought that was pretty neat. I very rarely get to work on train economizers. This is probably the second one all year I've even seen. The first one I've actually been able to really play around with.
While we're waiting for that unit, which I was just working on, to cool down so I can record a supply temperature, I came over to the twin to this unit just so I could show you exactly what tech support had me do to change this from a comparative enthalpy sensing economizer to a dry bulb economizer. First thing we did is we took our enthalpy set point and we set it to E, so it will go into free cooling at 55 degrees. Then we removed our outdoor air humidity sensor, our return air humidity sensor, and our return air temperature sensor. It's that simple. We are now set up to economize based solely on the dry bulb temperature, nothing to do with humidity. All right, guys, that does it for today's video. Hope you enjoyed it. Just a quick little video about economizers. Like I said, I have very rarely gotten a chance to work on train economizers, so it was a good learning experience for me, and I figured that maybe somebody else out there could benefit from it. All right, so hope you enjoyed it today, guys. Thanks for watching. I really do appreciate it. Click that like button for me if you get a second. Hit the subscribe one while you're at it as well, and go ahead and share some videos on Facebook. It's all right. I'm not mad at you if you do. All right, so for now, guys, that's it. We'll see you on the next one. All right. Hey guys, so today we are revisiting this murdered compressor from a video I did last week about the compressor where all three terminals blew out. Filter dryer was on the hot gas discharge line. The requoted job was approved, so I'm here today to repipe everything, switch out this compressor, contactor, filter dryer of course, and straighten everything out as best I can. So it's warm out, it's sunny out. I got my umbrella up. I got my cart full of tools down there. All you new guys out there, after you've been doing this for a couple years, you're going to want to invest in a cart like this, or at least a wagon, so you don't have to carry all this stuff across the rooftop. If you look behind me, that's a good, I don't know, 30, 40 feet. And even though I do need more cardio, I prefer not to get my cardio on rooftops carrying hundreds and hundreds of pounds of equipment. So I usually try to bring up my little cart, roll it across the roof, save my back a couple more years, you know. But let me flip this camera around and just revisit this situation we're dealing with before we get started, all right? Here is our little train unit, our 5-ton unit. As you can tell, everything's got a coating of oil on it, which is normal for this situation. Again, remember, we blew out all three terminals of our compressor. This was melted. Now, I was thinking about this on my last video. If you remember, I had pointed out this little pinhole leak. And for a couple days, that bothered me of how we had a pinhole leak. And I got to looking at it in my pictures, and it didn't look like a rub out. So I had a new theory. My new theory was that this blew off and maybe spun around, touched right there, because that looks almost like an arc mark. So that's what I think happened. I don't think it was a rub out. From my previous video, I think I said it was a rub out or just a pinhole leak or something, but anyway, I digress. So the first thing we're going to do is cut away a majority of this piping. This is all going to be repiped properly.
this line right here and this line back here. We're gonna have to repipe this hot gas discharge line, make everything match up the way it should have. And we'll have to put a new filter dryer in over here, of course. So I'm going to cut the copper out. I'm going to isolate the condenser, blow through it with nitrogen, get as much of that contaminated oil out of the system as I possibly can. We'll have a better chance of not recontaminating the new compressor if we can get as much oil out of this oil-logged condenser as possible. Because I'm 99% sure there's acid in the system, and the acid lies in the oil. So if I can get all or as much oil out as I can, then we have a better chance of, like I said, not recontaminating the system. So I'm going to isolate the condenser, blow that out, do the same with the evaporator. We'll blow that out. I believe this is a TXV system. I'll double check, but if it is a TXV system, it's going to be wide open anyway, because the TXV just thinks that it should open up because it's not sensing any superheat at the end of its suction line. So let me get a few things set up here, guys, and I'll bring you back when I start blowing some nitrogen through this condenser. We'll see how much oil is really in there. All right. Our condenser is isolated, and what I'm going to do is I'm going to blow through this high side. Actually, this, I believe, is our, this would be our liquid side. I'm going to blow it through here. I just got 50 pounds of pressure on it. I don't want the oil to really come shooting out. Yummy. Yeah, there's a little bit of oil left in there. I'm no super tech, but I'm pretty sure the condenser shouldn't have that much oil in it. And I don't believe the oil should look like coffee grounds. Now I know you guys can't smell it, but it's got sort of a bitter smell to it. So I would assume that smell is obviously acid or whatever is in the system. You guys think Tide Pods will get that oil out of that cloth, that towel that I got there? I have a feeling that's not going to wash out very easily. Really didn't think there'd be this much oil in there. All right, I'm going to crank it up a little bit. Move you guys over here a little bit because we're getting a ton of oil blowing out there. Alright, let's try to do this here. When I was first coming up in the trades, this is how I was taught to recover. Just get a towel, cut a line, throw the towel over the line, and let it bleed out. Obviously, we know better now, don't we?
that was my full tank of nitrogen. We still got some more oil to blow out of there. All right, guys, I'm gonna shut this off for a little bit, go refill my tank of nitrogen, and then we will blow some more oil out. Here's where we stand, guys. So as you can tell, I got my compressor cut out. My lines are all cleaned up. There's my condenser. I blew through the evaporator and the condenser. I got a bunch of oil out. There's just a pile of rags that I use to clean up after myself. I like to try to clean up as much oil as I can off the floor of these units. I got most of it out, but it's not perfect. But it's a little bit of OCD that I have. So now I'm just waiting on my compressor. I have another technician bringing me the compressor, contactor, filter dryer, all that. I'm really trying to push my customer to replace that condensing fan motor. They rejected my initial quote with that condensing fan motor. But today, now that I'm looking at it more, I really stressed the need to replace that. Common sense is you don't put a $1,500 compressor in if you're not going to change the 20-year-old condensing fan motor above it, because you run the risk of having that condensing fan motor fail, and then our brand new compressor will overheat, and then in a little while we're back to square one again. So I got everything all cleaned up. As soon as I get the new compressor in here, we're gonna set it in place, start measuring some pipes, and yeah, and we'll go from there. All right, guys? So I'll bring you back in just a little bit. Tech tip of the day. Down there you'll see our unit that we're working on today, and you remember our piping was a mess, and I just basically gutted all the piping out of it. So I came down here to this twin unit to try to pipe the unit I'm working on up exactly as it should be from the factory. So I just came over here and kind of measured this pipe, this hot gas discharge line, and we basically got it right on. So tip of the day, if you're ever in a situation like this and the piping is a complete mess and you don't know what you're gonna do, see if there's a twin to that unit and try to match it up best you can. All right? All right, guys, here's a look at our piping job right before we get everything brazed up. We got our high side pressure switch port right there. That's where our low side pressure switch port's gonna be. Right down here we're gonna have our service port, and I'm gonna put some couplers on here and strap this in place. We tried to do this without using a lot of couplers. We just swedged out our ends, put those in there. If you guys are wondering, that is the correct filter dryer from the factory. We just had to put a couple reducers on there, but I did verify that is the correct dryer. So everything looks nice and shiny. We're gonna braze it in place and pressurize it in just a minute. All right, real quick, just so the YouTube police don't come after me, just to show you that we are brazing with nitrogen. You can see the little bead in there floating, 3 to 5 psi, hooked up to one hose going into our suction side. And the idea is it's going to go through our suction side into the compressor. You can kind of feel it coming out here. It's going to come out here, go through our condenser, through our liquid line, through the dryer, to the evaporator, and we'll basically have all our bases covered, all right? Looks pretty good. I don't even know if the factory could do that good.
Let's transfer this rag there so that I can get both of these.
You're doing that second service port? As you can tell, we got everything brazed in place. We are currently sitting at 150 psi. We have no leaks anywhere. Our piping came out pretty good. nice and shiny. Everything fit the way we wanted it to. One thing I did want to point out to you guys, I've never seen this before, so I figured it's worth sharing. This is the wiring to our old compressor, and you'll notice our black wire goes to the incoming side of our contactor. Now, I had just assumed that that was wired incorrectly, so come over here to our schematic. Right down here, compressor 1, we follow our black. So our black does go directly to line voltage. Our contactor right there and right there, that just cuts off our blue and red power lines. So I don't really know what that black line is constantly powered for. I guess maybe a crankcase heater, maybe if it has constant power to it, that winding stays a little warm to keep refrigerant from migrating into the compressor during the off cycle. Yeah, I'm not real sure. So if anybody out there watching knows exactly why that black line is powered continuously, let me know. I'm curious to find out. But all right, guys, we're gonna let this sit under pressure for a little while longer, and then we'll pull a vacuum and make sure everything's really nice and tight. Here's where we're at. Pulled a vacuum, got it down to 170, valved it off. I valved this off at my gauge, so this is literally the lowest point in my entire system. That's what we pulled through. Yes, I did leave the Schrader cores in the high and the low side. I know that is a restriction, and I also know pulling through my gauges is a restriction. However, the system's so small, it doesn't really warrant the use of the True Blue hoses that I do not own yet. But we did get 170 microns out of this system. It's probably been valved off for about 10 minutes-ish, 10-15 minutes, and we're holding tight at 200, so we're gonna go ahead and charge this thing up. It takes 4.9 pounds of R22, and we use the real R22. We're not doing any sort of drop-ins or anything like that, so let's charge it up. Now, whenever I'm charging up a system like this, I usually account for at least 1 to 2 ounces of refrigerant per hose, assuming that maybe I can pull maybe a ½ ounce out of each hose when I disconnect my gauges properly. So we're gonna go over just a little bit. Just about 3 pounds. It's cruising along, so we should have no problem getting to 4. 4 pounds, 2 ounces. And I want to get about 4 pounds. I figure 4 pounds, 12 ounces should be just enough. Yeah, we may have to pull the rest in through the low side. All right, looks like we have to pull the rest in through the low side. We're stopping at about 4, if you can see that on camera. 4 pounds, 3 ounces. So what we're gonna do, what my buddy Jason here is gonna do, we are going to valve off our low side like so, and valve off our high side, and then you open up that low side on that gauge, Jason, just a little tiny bit, and then now our gauges are basically purged, so you can pull that micron gauge off there if you don't mind. Just be careful, there's a little bit of refrigerant that's going to come out of there. That's what we call de minimis maximus. Alright guys, we're all just powered it on a second ago, and I think it's running backwards, so we're going to power it on again just so you can hear it running backwards, and then we'll switch some wires, and then we'll fire it up again so you can hear the difference. See, that right there sounds like it's running backwards. You see we have no differential on our pressures. So now what we're gonna do is we're gonna switch 2 legs of power, and then we'll start it back up. We got 2 legs of our compressor switched around, so let's see how it sounds now.
It's a much smoother sound right off the bat, and we're immediately getting, let me close this off. There we go. Immediately getting a pressure differential. Of course, my low side is now pumping down into a vacuum, and we are shutting off on low pressure. All right, that's different. Want to kill that, Jason? Huh. Well, we are fully charged, so keep in mind we did flush the system with 2 tanks of nitrogen and RX11. So let me pull this panel open and we're going to check our metering device. We might be plugged up. Picking up where we just left off. So our system basically just pumped itself down and shut off on the low pressure. And we were short cycling on the low pressure switch for a few minutes. So here's what we got going on, I think. Right here, this is our suction line. This line right here, this is our liquid line. And in each one of these little lines right here, pinched off inside here is a little piston. This is our metering device. So we have pistons all throughout here. So they feed in through here, go through our evaporator, come back out to our suction header. And then our suction header goes back to our compressor. Now, when I had the old compressor out, I isolated the evaporator and I blew nitrogen through it. And it came out the other side along with some oil. Hindsight, I think maybe I should have had more pressure coming out, but I did get a bunch of oil and a bunch of other garbage out of there. Like I said, I went through 2 tanks of nitrogen, probably about a tank and a half on the condenser, about another tank or a half tank on the evaporator. But what I'm thinking maybe is that I was just blowing through maybe half of these instead of all of them. So what I'm going to do, and this is probably not recommended by the manufacturer, but I'm going to take a heat source and warm these up a little bit. You can figure out what kind of heat source, but I'm going to take a heat source, warm these up a little bit, and kind of just tap on them a little bit, see if I can't free up some of that oil, some of that garbage that might be in there. And yeah, well, we'll go from there. I might end up reclaiming this charge and re-isolating this evaporator. If I do that, I'll probably just end up cutting it right here, and then we'll just have to flush it out again and then brace it all back together and do this whole process over. So it may be a long day, guys. So I went through, I heated all these little pistons up with the heat source, and as far as I can tell, it really didn't do anything. We're not down low enough where our low pressure switch is cycling us off, but we really shouldn't have a negative 20 degree evaporator. And you can tell right here where some of these are starting to frost over. I believe these are the ones that are probably blocked off, or maybe not. If I had a thermal imaging camera, I would be able to see a lot better which circuits are working and which are not. We got frost on this one, frost on this one, frost on this one, and frost on this one. None of these other ones are frosted up. So it could be that these are all blocked off and these are open, and since there's so much pressure going through there because this machine's trying to put enough pressure through there to feed this entire evaporator, there's so much pressure going through here, maybe it's just boiling off right here at the inlet of the evaporator. So it looks like we might have to isolate this evaporator and try to get those pistons clear. If not, what we have to come back and do is we have to cut this liquid header. We have to cut it right off and then try to braze in a new liquid header with pistons pre-installed. So let me call our person who's paying the bill and see what kind of options we got. Here's where we stand, guys. So this is all plugged up. I did take a heat source, like I said, tried to free it up, but that didn't work. That failed. So I have two options here. I was kind of bouncing ideas off another technician. first idea was to just replace this liquid header, and in order to do that, of course, we'd have to cut this, cut apart this suction line just to get this liquid header out of the way. I'd have to go through it. I'd have to cut in between each one of these tubes so I could unbraze it out of the evaporator, because of course you can't unbraze this whole thing at the same time because there's, I don't know, about 10 of these little tubes going into the evaporator. So that's a very labor intensive option, and I still might not get all the contaminants out of that evaporator. Even if I put a new header in there, we purge it, blow nitrogen through, RX11, acid scavenger, whatever I can blow through there, I still might not get everything out of there. So our other option, which is probably less labor intensive, is just to swap out this evaporator, assuming that it comes with new suction and liquid headers. So that I'm going to have to talk to the person who pays the bill on this account and run those two options by them and see what they want to do. So it looks like this went from a part 2 to it's going to be a part 3 to this video. So we'll go from there and have to come back here and swap this out, I suppose. Yeah, so something I've never seen in real life. I've read about this, heard about these blocking up, and really it's no surprise. I mean, like I said before, there was all sorts of contaminants in that condensing coil from that filter dryer being in the wrong spot. So who knows what ended up in that evaporator in those little tiny orifices. But anyway, guys, that's all for now. Assuming that the customer does want to replace that evaporator, of course they've already invested quite a bit of money on the rest of this, so they probably will. We'll come back and we'll film what I hope to be the end of this trilogy. All right, guys, thanks for watching, and yeah, we'll see you on the next one. All right, guys, here's our call for tonight. I didn't quite make it through the weekend without getting an overtime call. So here's what we're dealing with. Walk-in freezer, they said, isn't keeping temperature. It's getting pretty close to 0 degrees right now. We're of course going to go through and check everything out as we normally would, but real quick, I wanted to give you a tour of a pretty rundown walk-in cooler here. Yeah, see that right there? In my opinion, is going to leave a lot of room for moisture penetration. See over here as well. And we get up here. Yeah, you can actually see through there. Now this cooler, we have recommended many times that they just have it torn down and replaced. They have not done that yet. So this is what you get. However, this walk-in cooler is not really our issue. Let's check out our freezer. Alright, looks like we are at 0 degrees. Now this freezer isn't too bad. However, if we look right up here, there's actually a dip. Right here is the end of that dip, so the ceiling's actually bowing down, and I've been here quite a few times, and what they have going on here is there's a roof leak above this. And one of my first visits here, this entire ceiling was just full of ice. I'm sure it probably still is, but the roof had started leaking, the ceiling filled up with water, then it would freeze and expand. I mean, it's got a lot of issues here. But so if you notice, like right over here, you can see we got a space right there. Not so much on that side. Back to the matter at hand. You'll notice got a little iceberg right there. Now that honestly is not a surprise in this location, because the roof leak has not been fixed yet, so it still leaks sometimes. They still get water penetration and moisture penetration. Despite our recommendations and our quotes to repair, they never ever actually approve any quotes. So Alrighty guys, let me move some of this stuff out of the way. I'm going to climb behind that coil and just do a general inspection before we get up on the roof. Alright guys, here's our condensing unit right here. Looks like it was built in about 1937. I really don't know how old this unit is. I can see a little bit of that data tag, but for the most part it's just whitewashed. Not even sure what kind of refrigerant we would have in here, so hopefully it's written down somewhere. Hopefully it's written somewhere on the inside here. First things first, found myself a new wrench. That's cool. A pile of service caps. You'll notice right there, apparently somebody just didn't want to put the service caps back on our king valve on the receiver. And if you notice right there, we have a bubbling sight glass, a rusting out suction dryer. Accumulator's not too terrible. Looks like both our fans are going the right way. My condensing coil is pretty much clean. So it appears all of our electronics are functioning. Fans, compressors, thermostats of course. And our evaporator coil and condensing coil both seem to be pretty clean. This condensing coil couldn't hurt to give it a little bit of washing because I can't see through it, but the inside surface and the outside surface are both clean. However, that doesn't necessarily mean the middle part of that coil is clean, so we may have to address that tonight as well. So right now all I'm looking at is our bubbling sight glass. So I think it's about time to gauge up on this system and see what we're dealing with. Grab my electronic leak detector, we'll sweep it and gauge up to it and see if we can't figure something out. But on a side note, I was able to kind of figure out the refrigerant. There's a little label on top of the compressor. It's R404 or 507. One of those two. Now I'm just going to make an educated guess and assume that it's 404 because that's just a more widely used refrigerant in my opinion. So I'm going to go ahead and assume that it's 404. Let's get our gauges attached here, but first what I want to do is I want to check my Schrader ports before I put my gauges on. Nope. Got no leaks. Nothing there. I got a slight hit on my receiver. All right. Power that down because I'm sure those fans are messing with my test. And my battery's getting low. Alright, well, maybe I just got a false hit there, I'm not sure.
See, I'm not getting any hits in any of the obvious places, like around the top of this, or even the bottom of these accumulators will rust out sometimes. So nothing there. These suction dryers, I've seen these rust out and leak numerous times. I kind of thought I'd get a little bit of a hit right here. It's rusted pretty bad up on top here. But so far, getting nothing out of there. Alright, let's get some bubbles. You can see right down there. See if I can point this out if the camera will focus. Right there we go. Right about there. Getting a little bit of something, not much, but looks like I'm getting a little bit of seeping. It's hard to tell. Those bubbles are honestly moving so slow, but they are moving. Just the littlest, tiniest leak in there probably. Now on this accumulator, I don't see anything. The suction dryer should be repiped now. Not getting anything out of the king valve on the receiver at all. Check our stem. Oops, not a very good shot with this. I just kind of shoot it all over the place. Check those with my electronic leak detector real quick. Getting a pretty substantial hit right there. That liquid line, not so much. Our suction line. Yeah, we definitely got a leak right there. I'm gonna check this receiver king valve again. I'm getting a little bit around the stem of this. There we go. Pull it back, let it suck in some actual air and sort of reset itself. And we go back in again and we still have a leak. So I'm going to try to confirm that leak around the stem of that with some bubbles. And then what we'll do is we'll just get you in a little bit closer. We'll probably just take this packing nut that's right there and tighten that up a little bit and see if we can get our leak to just go away the easy way. check out our suction line king valve or queen valve, or service valve actually. We got some bubbles coming up slowly to the surface. I was getting a pretty good hit on there with my electronic leak detector, so I was hoping for, I guess, more bubbles anyway. Yeah, if you look right down here, focus in. It's hard to see, but you can see some of those bubbles moving. Let's see if I can get this out away there. It's not really picking it up well on camera, but there are some bubbles coming up from the bottom of that Allen wrench hole, I guess you'd call it. I'm sure there's a technical term for it. So I think we need to go downstairs and leak check everything as well. Alright guys, just wanted to take a minute and acknowledge something here. As you've seen, I was getting some hits around this valve with my electronic leak detector, mostly on the inside here, and then you've seen me fill it full of bubbles. Now, I don't normally like to do that in this particular situation because obviously on the low side you run the risk of pulling those bubbles into the sealed system if there is a major leak over here. So I do have the system off, so it basically was under positive pressure. However, I am going to clean it all up and get as much of that bubble solution out of there as I possibly can for that very reason. I don't want to pull, even on this, I'm going to wipe this off too. I don't want to pull anything into that, into the low side if I can avoid it. So that's my line of thinking with that idea, I guess. That's my line of thinking for this situation, rather. Alright, let's go down inside the box and sweep that with our electronic detector. Alright, here we are at the evaporator. Let's see. Right where I'm going right now is my TXV. Alright, let's get a better view of this. Don't see any oil stains, so really all I'm trying to do is hit around all of these elbows, all of these U-joints. Alright guys, let's look into this iceberg a little bit. Yeah, it's been there. It's been there for a while. Alright, so, I don't know if it'll pick it up on camera, but it looks like we have water coming in somewhere inside this line set penetration. I can barely reach it back here, trying to shove my giant body in this this little space between the evaporator coil and the wall here. But it looks like it's dripping out of there. When I was here the very first time, they had the same problem, and it was much worse, I suppose. And also, guys, we're not the only company that comes out to this location and services it. So all that caulk wasn't there the last time I was here. So I'm gonna add that to my quote to I don't know, maybe dig out all that caulk, or I'm not real sure. I don't know if it's a problem that can be fixed simply by recaulking that hole. Because like I said, they had roof leaks, which led to the ceiling of this walk-in freezer filling with water and expanding, and we had all sorts of problems then. Let's see if I can get this on camera, but if you'll notice right here too, hold on, let me get you a better angle, guys. Alright guys, if you'll notice right here, our liquid line, I'm not real sure why it's done this way. It seems kind of odd to me. They have an upside down trap on our liquid line, and to be honest, I've never seen that before. The trap on our suction line, of course, that makes sense, you know, for proper oil return and whatnot, but literally our condenser sits right above us, maybe 5-10 feet at the most. So if any of you guys know why they would have a upside down trap on our liquid line, let me know. Doesn't really make a whole lot of sense to me. I've never seen one like that before that I can remember, and I've never read any reasons why that would be like that on a situation like this anyway. Yeah, I don't know. Seems odd to me.
Alright guys, you may notice I'm kind of rushing around. This place closes in about a half hour, and at that point I'll have nobody on site to sort of babysit me, I suppose. But real quick, I just got back up here. I don't know if you can hear it, if it's picking it up on camera, but our liquid valve right there is making some noise. And I'm not sure why right now. See? There we go. So, let's see if I can get in there and just tighten that Schrader core up, but there's a long list of things I'm going to end up quoting for on this job. So, I think instead of connecting right there, I'll just connect over here. I'm going to seal that cap up. And like I said, I'll just connect right over here then, make it a lot easier on me. Here's where we're at, guys. My sight glass is still bubbling a little bit, if you can see it back there. We're losing daylight, so I'm kind of putting a rush on things, and they close in about 20 minutes now. I was just checking my pressures across this dryer to see if it was causing any sort of restriction or not, or anything like that. We're not. I got maybe a PSI drop from the top side to this valve over here, so I'm not too concerned about that. So as I was going through this, I was thinking about what I would have to quote to repair. Whenever I find these leaking, I just quote to have them cut out, and I'll just pipe it straight through with a service port on there. The same with the liquid line, and then I usually come back and I'll cut out this suction dryer and pipe that straight through. However, on this system, where it's at least 20-30 years old, it's original to the building, and I know the building is 25 years old maybe, so this has got to be almost 30 years old, I'm guessing 20 plus at the very least. So what I'm going to do is I am just going to quote them a new condensing unit and evaporator coil, and yeah, we're going to be done with it, because this is just a really old system that either is operating on 404 or 507, I think it was. So that's what we're going to do, guys. All right, but for now, I'm going to clear this sight glass and make sure that box gets down to 0 before I get out of here. All right, guys, let's see how we're doing in our box here. All right, looks like our return is down to about 9. When I opened the door, you saw it spike up a little bit. Check over here, we're doing about 5 degrees right there. So we're just about satisfied. Ready to get out of here. I'm just adding to the load on the box. All right, guys, so we're just wrapping up this service call here. I'm down to about 2 degrees right now, just about ready to satisfy and shut off. So just a quick recap. The complaint was the freezer wasn't maintaining temperature. When I got here, it was about 5 degrees-ish. The kitchen manager said that it got up to 15 at some point. However, I wasn't able to verify that. The defrost clock was working, it was spinning. I didn't get a chance to show that on camera. It did have, I think, 3 45-minute defrosts set in. But I guess the main focus point of my service call was the bubbling sight glass. We were low on refrigerant. I found a couple little leaks. The suction dryer was weeping the valve on the receiver. I was getting a slight hit on that, but I couldn't verify with bubbles. The suction line valve at the condensing unit was leaking. So a couple little leaks. I didn't find anything in the evaporator. So I gassed it up, kind of sealed up the caps with a little bit of leak lock, and we're getting down to temperature. I'm going to get out of here. But I am going to quote to replace the evaporator coil and the condensing unit. I may end up also putting a quote in for repairs because this customer doesn't really like to spend money, so I might end up just coming back and repairing it. But who knows? It's hard to say sometimes. Sometimes you put a quote in and they just never want to do it, or they go with the cheapest guy. Usually my customers will get 3 quotes and they just go with the cheapest company. And then a couple months later I come back and re-quote it because whatever they did is usually wrong, or not necessarily wrong, just not done in a way that would last a long time, I suppose. But anyways, guys, it's late, it's Sunday, it's about 10 after 9 where I'm at, so I'm gonna watch this drop 2 more degrees and I'm gonna get out of here, all right? You guys have a good night. Thanks for watching. If you get a chance, hit that like button, and if you're not already subscribed, might as well subscribe while you're at it, right? All right? Thanks for watching, guys. We'll see you on the next one. Stay curious, all right? All right, guys. Here's our project for the day. We got a 12.5 ton York unit that's not cooling. And our issue is we don't have any control voltage going to our board. It's kind of bright out here, so I apologize if there's a glare on any of these components. We have a phase monitor. Our phase monitor does not indicate any faults. So let's go ahead and check some voltages here. So I have one lead going to a common side on the contactor, and I'm just checking 24 volts. So I got 27 volts coming out of my transformer. Now this red wire right here goes over to my little 3 amp popper that's back there, and then from that 3 amp popper it comes back around on this wire. So let's check right here, 27 volts, and assuming that this doesn't have a fault, which it doesn't, we should have 24 volts coming out of this side, which we do. Now this wire right here goes up to our SD on our control board. Let me pull that right out of there. It's all flopping around. Got some hands in the way. Alright, so we got 27 volts on this wire going into our control board. Right? Let's plug this back into our board. Now if you notice, right when I plugged it in, that board lit up. Now it does that from time to time, whether I pull that off or whether I reset the breaker or reset this phase monitor. I haven't found an issue with this phase monitor yet, but what I have found is whenever I pull this wire off, not whenever, but sometimes when I pull this wire off or reset it, or reset the breaker, that board will light up again. My initial theory is that somewhere in that board, or one of the circuits that goes to that board, I have a low voltage short, and that's what's dropping out my voltage to that board. But I haven't been able to confirm that yet. That's my only theory. I've unhooked the low voltage side of my contactors because at first this board would light up, and then my indoor blower motor would come on, and then about 2 seconds later that board would power down. I would have no more no lights.
I would still have 24 volts at the board on this wire right here, but I would have no lights, no action, no output, no 24 volt output. Right back here is my 24 volt output. I would have no output to that. I would have no output to my EMS board right here as well. So I'm not real sure what's going on, but that's my theory. So I'm gonna put the camera down and explore that theory for a little bit and bring it back around when I'm all set. Real quick before I forget, guys, I want to highlight another thing right here. My 24 volt output from this board, right back there, if you can see it over my giant hand, I do have 27 volts, and that voltage comes over here to my inducer board, my ignition board, not my inducer board. Probably can't see it very well on camera, but that light is flashing in heartbeat mode. So this ignition board seemingly is okay. It's getting power from the main control board, but my main control board doesn't have any lights on it. Now I know you're probably thinking, well, that board is bad. You could be right. However, that unit right over there has the same exact issue. So right over there, our guy Jason is going to switch that board and another board because we are having the same exact issue on all these units on this rooftop, which is bizarre. So we're swapping boards out with another unit that we know works from another part of the building, and we're just going to see if that problem follows us. So let's continue to work on this, all right? Like we got a fault code maybe. Seven flashes. Let's see what 7 flashes means. Free stat 1, compressor lockout. Alright guys, let me bring you up to speed on what we got going on. Been running without issue for about 20-25 minutes now. I did look at our freeze stat. I pulled it off. Right there it is. We were getting a freeze stat alarm. Of course, that freeze stat has failed because we weren't actually froze up because the unit wasn't even running. So I just bypassed the freeze stat, clipped the wires, put a wire nut on there. We've been running fine since. I did check this freeze stat to ground just to see if maybe the casing had shorted out, but I didn't get anything. It wasn't shorted to ground as far as I could tell, but I don't know exactly what our problem was yet. Like I said, we haven't lost power again, and just so everybody knows out there, I did check power going into my transformer. I had 209 volts going into it. My phase monitor says 210. I had 26 volts coming out. I had voltage here, everywhere I'm supposed to have 24 volts going into the board and coming out of the board, I did. However, I had no lights on my board. And again, that unit right there, same exact issue. Except that one over there doesn't have the freeze stat problem. So, I'm kind of sad because I don't get that instant gratification of actually finding a problem. So far, my only theory is that this freeze stat possibly was shorted to ground somehow, and that when that board came on initially, because it would come on when I reset power, when that board would come on initially and check its logic circuit or safety circuit, it would, I don't know, short out through this freeze stat somehow, and then my voltage would drop from that board, and then I wouldn't have proper power inside that board. I don't know. I'm just kind of spitballing ideas here, guys. This is one of those non-instant gratification videos, I suppose. So let's let this run for a little while longer. Maybe we'll pop over to this other unit and see what's going on with that one. There's the unit we were just working on. Now here's the twin to that unit. We're having the same issues here. Right now I have power off. I'm going to cycle my power back on because that's usually what will cause this board to come back on and run for a little bit. Let's see what happens. Phase
monitor's on, board is on. You see right there we have our heartbeat light. Get the focus, there we go. So now we're just going to watch it for a little bit. Right now my indoor blower is on. There's verify, show you that I do have voltages. 27 volts. My output from the board, 27 volts. I have 27 volts going into the board. And right there it just shut off. I have no more heartbeat. My indoor blower stopped running. However, I still have 27 volts. Still have 27 volts on my output. And we can even check right here on my 27 volt or 24 volt input to the board. If I can get my hand in there. There. See, 27 volts. Now my little popper isn't tripping. Down there you'll see that's not tripped. So once I pull power off that board and reset it, it does come back on. And it'll do this for a little bit. It won't flash any fault codes. That double flash right there is just our heartbeat signal. So it won't flash any fault codes. It'll just do this for a while, start up and run, and then power itself off. Right now we just have the indoor blower motor. All right, and it's off again. Here's an update for you guys. It took me a little bit longer than it probably should have to find this issue. But anyway, I believe I figured out our problem. So again, we're still off. We still have voltage here. We still have voltage going to the board. However, what I've discovered is our smoke detector is in alarm mode. See our little red light there? Now I tried to reset it and it won't reset. So either we have a bad smoke detector or maybe our sensing tubes are plugged up. But right back here on terminal number 6, you'll see we have 27 volts right back here. Now this terminal, number 6, is supposed to be closed through number 16. So this red and yellow wire are basically supposed to be connected. However, when it's in alarm mode like it is, these two wires will open up and separate. So now let's think about this for a second. 24 volts comes in at number 6 right here. If this is closed, it'll come out our yellow wire right here. That yellow wire comes in right over here, goes down through here, up through our filter compartment, and comes right out over here, number 254. And since we don't have a supply air smoke detector, we have a jumper in place. So that jumper routes our 24 volts back over here to, I believe this wire is number 247 over here, but then it turns into 225 over here and lands right here on this control board. And that's why we're not powering anything up, because this control board needs to have a 24 volt signal telling it that the smoke alarm says, hey, the building's not on fire, let's go ahead and proceed with whatever we're gonna do today. So that's my issue. That is the gratification for today that I was hoping for. All right, so let me put this camera down, guys. I'm gonna pull the smoke detector out, inspect the sensing bulbs, or sensing tubes rather, and see if they're clogged up, see if maybe I can reset it, clean those out, and get it up and running, all right? I got the sensing tubes all cleaned out on this smoke detector, and if you look right in there, I put the cover back on just because I didn't want it to sense any outside air and have any influence through that. I wanted to sense right through its sensing tubes. And really all I did was, take the screw out, lift the whole smoke detector out of the unit, and then I just cleaned the tubes out using some nitrogen. But if we look right over there, you'll see a little tiny green flash Right there. So that means our smoke detector is good to go. Alright guys, that does it for today. Hope you learned something. Hope you enjoy watching the video. Hope you enjoyed watching me scratch my head for about 20 minutes there on a problem that should have probably taken me less than that. But you live and learn. This is one of those lessons that I'll never forget. So I hope you guys pick something up out of this. And we'll see you on the next one, alright guys? Thanks for watching.